So let's say you found a skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. Today we're taking a look at a video from the channel Spiritual Strength with Gene Zanetti. This is a Tradcath channel with conversations about things like interpreting Genesis with known traditionalist Eastern Catholic creationist Gideon Lazar, radical traditionalism with Pedro Gabriel, and our current focus, Geocentrism with Robert Bennett. Geocentrism is basically a mild version of Flat Earth. Like Flat Earth, it says that the Earth is the center of everything, and that all the stuff in the sky, like the sun, moon, stars, and planets, actually orbit or circle the Earth. Unlike Flat Earthers, though, geocentrists can actually produce accurate maps and use their model for things like celestial navigation. So they're at least a step up from Flat Earthers. But at this point, we have precision measurements of the distance to various planets, the sun, and the moon. So let's just look at the two models side by side. Notice these models include only the Sun, Mercury, Venus, Earth, Mars, and Jupiter. No moons are included, and the orbital sizes and speeds are accurate to about 3 decimal places. And the orbits are simplified to be circular. But look at how the planets wobble around in the geocentric model. What could possibly explain this? What forces act on these objects to cause them to go towards and away from Earth? Nothing about this makes much sense compared to the heliocentric model.
Hey, Editing Dapper here. I just wanted to point out that the way that I had to make the geocentric solar system simulation is by making an actual heliocentric system and then just locking the camera to Earth. It would actually have been a gigantic pain in the ass to try to make an accurate simulation of a geocentric solar system, so I didn't.
Now, I do want to point out that heliocentrism is strictly wrong too. Everything in the solar system, including the sun, actually orbits the solar system's barycenter, or center of mass. Now, that's close enough to just being the sun that most of the time it doesn't really matter, so I will refer to the barycentric model and the heliocentric model interchangeably for this series. Just know that technically they are not the same, and the barycentric model is more accurate. Robert Bennett is the author of Galileo Was Wrong, The Church Was Right, and I cannot seem to find any biographical details about his credentials. I, of course, would like to point out that Galileo was not condemned for simply thinking the sun was the center of the universe, but for going around censors and the direct orders of the Pope to write a book with an overview of all the cosmological models then in contention, without favoring his own. Now, of course, I think it is entirely wrong for any religious body to control who can publish what, and for any such body to have the power to actually punish those who publish things they don't like. But anyway, this is already becoming one of my longest intros in the channel's history, so let's just get into it without much further ado.
And welcome back to Meeting of the Minds.
Thanks, although it's my first time here.
Today I'm here with the great Robert Bennett.
Not sure I'd agree with calling him that, but hey.
Expert, you name it, he's got it. He's here to give us some great information on geocentrism.
Well, that's what I'm here for. Although, what I'm not here for is anyone telling me that the Bible or the magisterium of the church says that the Earth is the center of the universe. I don't care. I'm only here for empirical evidence. If the church says something and the empirical evidence goes against it, well then, that sucks for the church. If, on the other hand, the empirical evidence agrees with the church, then hooray for them. But for me, that the Catholic Church teaches something doesn't really mean anything.
On the Catholic Church, on history, like I said, he's our man.
How about astronomy, physics, orbital mechanics, etc.?
He's the scholar of the night. So, Robert, thank you for joining us.
Oh, great to be here. And I don't know about the great part.
I guess Robert agrees with me on something then.
All right, so let's take it from the top. Let's start off with everything a historical perspective.
Oh, this could be interesting. Generally, I don't find that Tradcaths are super great at history. They tend to do things like just accept hagiographies as historical, think that papal supremacy actually goes back to St. Peter, think that the Crusades were only ever about protecting pilgrims and bullshit like that.
Okay, the clash between geocentrism and heliocentrism really goes back to the beginning of the Christian era.
So, like, back in the middle of the 1st century? I'm going to need a citation on that one. I'm not aware of anyone in the 1st century arguing against geocentrism. We didn't even really have a way to measure the distances to planets at that time, Although we had managed to work out that the Earth was round, that the Sun was much bigger than the Earth, and that it was much farther away than the Moon, which was smaller than the Earth.
When everyone believed, both in science and in the church.
Well, science wasn't really invented until the modern period, although naturalists and natural philosophers variously came close before that. So I don't think it's reasonable to say that in the 1st century CE, people had both science and the church. Of course, we also don't know all that much about the 1st century church, so it's not even easy to say what the ecclesiology of various Christian groups were in the first couple centuries of the Common Era. So even the idea of believing the church is hard to pin down.
That the Earth was the center of the universe. So that was true for 15 centuries, until the 1500s.
Yeah, I'll say that's reasonably accurate. Of course, I'll note that this stops being true, even by Robert's suggestion, at about the time the scientific method is developed, and we can start actually doing rigorous empirical research, observations, and experiments. Weird how the development of a rigorous scientific method and the abandonment of geocentrism seem to go hand in hand. It's almost like science pretty much has never supported heliocentrism, and instead, what did was pre-scientific natural philosophy.
Why did science believe in this?
It didn't. The thing we know of as science did not exist before the modern era. There were things called science, of course, but they were not what we now think of as science. Modern science is a method of gathering empirical evidence, forming hypotheses, and testing those hypotheses, while making your testing methods available for corroboration or falsification to others, as well as the body of knowledge thus obtained.
Well, that was the observation that you make with your own senses. Your eyes tell you that everything moves through the sky, and the Earth seems to be at rest.
Yep, that's true. But one of the things we realized right fast as science was developing is that human intuition and human senses are horrible judges of reality in many cases. Look at this pattern. It seems like it's moving, doesn't it? But it's not. If you could see my editing timeline, you'd see that it was placed as a single image file. Even if it were part of an animation originally, it isn't now. Why do you see motion? Well, your brain has a bunch of heuristics sort of built in that tell it that motion is to be inferred from certain visual cues, and while these cues often are the result of motion, they don't have to be, and so your brain can be tricked by presenting it with visual cues out of context. So clearly, your eyes aren't a reliable way to measure reality in all cases, but illusions also work on your ear. What you're hearing now is called a shepherd tone, and it seems like it increases in pitch continually, even though it's actually a sound loop that can run indefinitely. It's actually overlapping tones that each independently increase in pitch because of how they overlap. Your brain only notices the increase, and that's constant, so despite the fact that the pitch only varies within a narrow range, you hear it continually getting higher. Clearly, human senses are pretty good, but they are not perfectly reliable. That's why we use measurement devices. They allow us to take things that are beyond the limits of human perception and bring them within those limits. Microscopes and telescopes magnify things that are too small or too far away for human eyes to be of much use. As a result, human eyes can be used to investigate things like the distant universe and microbes. Theodolites and sextants help us measure angles with more precision than the unaided eye. Rulers and measuring tape allow humans to measure distance with more precision than just estimates based on visual perception or how many steps you took. Going past human senses is possibly one of the most important things technology can do.
So no problem with science. And with Scripture, we have the testimony that I'll go through in detail later, which describes the foundation of geocentrism.
Well, I would agree with Robert that the Bible certainly portrays the Earth as stationary, and it's no big leap from that to saying that it's the center of the universe, although I actually am less confident that the Bible is explicit on that. But here's the thing. Something being said in the Bible is not actually reason on its own for it to be accepted. The easy way you can tell that's true is just by noting that the Bible contradicts itself, which means that it's not always reliable, which means you need outside corroboration if you want to present its claims as true in history, archaeology, anthropology, physics, etc. So,
if this is a perspective, we should think of what happened after 15 centuries to change the mind of science.
Better observations, more accurate predictions, and eventually actual space travel through various national space agencies actually using models of the solar system to send mostly robotic probes to various celestial bodies, and in many cases return such robots to Earth after they have gathered samples.
So what we have is in the 1st century AD, a model which was proposed by Ptolemaeus, an Egyptian.
Well, more likely a Roman, as his name was Claudius Ptolemaeus. But he was living in Roman Egypt, in or around Alexandria, so I guess he was Egyptian in the same way that an average European-descended person in North America might be a Floridian. They're certainly not part of any native group of Floridians, but they do come from there.
And what he did was propose a model that shows the Earth in the center of the universe, and his model showed every object in the universe orbited the Earth.
Yep, and he did not have well-defined distances for these objects, and his math required multiple unexplained epicycles, which were kind of like suborbits within the main orbit around the Earth. You can think of it kind of like Russian nesting dolls, but for the orbits of various heavenly bodies around the Earth. These were there to explain the retrograde motion of the planets. Everything in the Ptolemaic model orbits around Earth counterclockwise when viewed from above the North Pole. And overall, the period of all these orbits is about a day, but not exactly. All the planets, including the Sun and Moon, traveled through the sky along paths that varied throughout the year or month. And in the case of all of them but the Sun and Moon, sometimes they traveled faster than the background stars and sometimes slower, meaning that sometimes they would move west through the sky compared to the stars, and sometimes east. When they're going east, that's retrograde motion. Ptolemy suggested that the planets were actually circling around some point along their path, and that the path itself circled the Earth, creating a spirograph-like path for the planet. This neatly explained the retrograde motion of planets, but was not a physical phenomenon with any explanation. No one knew what forced the planets onto their paths or what kept the epicycles going. They just did, according to that model.
Now, Galileo was both a Catholic and a scientist.
That's true.
And at his time, there was a book proposed by Copernicus, a monk, which proposed that the Earth was not at the center, the sun was. So this is a heliocentric model proposed by the monk Copernicus, and it established, he proposed that it showed that the church was wrong, that we didn't have a geocentric universe, we had a heliocentric.
He did, and his math was far, far simpler, which was the attractive thing about it. He could explain retrograde motion without requiring epicycles. By simply allowing the Earth to also be orbiting, retrograde motion was simply a matter of perspective as the Earth wheeled through the solar system along with the other planets, all with different orbital periods. The problem with Copernicus, which was not really solved by Galileo, was assuming that the orbits were circular. As a result of this, the Tychonian model and the Ptolemaic model were actually capable of more accurate predictions, which means that from a scientific standpoint, they were the ones favored by all the data that were available at the time of Galileo. Remember, in science, if you have two competing ideas, the one that better explains the data is the idea to be favored. And for a while, heliocentrism wasn't able to better explain the data. It took Kepler and his laws of planetary motion to bring heliocentrism up to parity in terms of predictions with earlier models of the universe. And remember, until much more recently, the solar system and the universe were basically thought of as the same thing. And it wasn't until very recently that the idea of the Milky Way as just one galaxy among many was even proposed. The history of astronomy from the 1500s on is a story of humans realizing how much bigger the universe is than they thought, and that happening repeatedly.
This is where physics challenged the geocentric theory for the first time.
I'm not really sure what that means, but in terms of current science, physics simply could not account for the Ptolemaic or Tychonian models. By the way, the Tychonian model says that the Sun and Moon orbit the Earth, but that the other planets all orbit the Sun. Both the Ptolemaic and the Tychonian models do not have a physical explanation involving things like forces, acceleration, momentum, etc. You know, all those things you learned about in high school physics class. The only model that actually takes into account all that we know about physics, and that can use the equations of physics to predict future states of the solar system, is the pericentric model, or less accurately, the heliocentric model.
3 centuries later, Darwin would challenge the book of Genesis, that is, challenge Scripture with its proposal of evolution.
Let us pray. Our Darwin, who art in the British Museum, hallowed be thy name. Thy evolution come, thy selection be done, on land as it is in water. Give us this day our daily sexual selection as we sexually select, and lead us not into inbreeding, but deliver us from extinction. Amen. Also, Darwin was a he, not an it. Maybe we don't need to dehumanize him. I don't know, just a thought.
And so that's what we've had, a basic breakdown in the agreement between science and Scripture.
Well, since science is based on empirical evidence and Scripture isn't, I'm going to side with the empirical evidence.
First, in the 15th century, based on geocentrism. 3 centuries later, we've had the break in biology with Darwin. And then I'll cover what modern theories are later.
Sorry, he just kind of trailed off there. Maybe he needs more coffee or a nap. I sure need a nap, but instead I'm here slaving away over a hot keyboard, all in hopes for some YouTube crumbs. If you want to help with that, feel free to join the Patreon or the channel membership program. The Patreon is linked in the description and starts at just $1 a month. Joining the channel can be done with the join button under this video on YouTube. It starts at $1.99 a month. Both give you early access to videos like this, as well as access to my supporters-only Discord, where you can hang out with like-minded individuals, join our twice-a-week watch parties, and interact with me directly.
Okay, so the basic problem is that there is a false belief in this separation that occurred in the 15th century.
So far, I agree. There is indeed a false belief, but I bet we disagree on which belief that is. Also, I figure I might want to explain why I'm responding to this guy and not Robert Sungenis, who is a better-known tradcath geocentrist. And frankly, it's because Sungenis' material is full of irrelevant tangents, philosophical musings, Bible verses, and other stuff I don't really care about. This guy is mostly on topic from what I've been able to see, so I can actually get to respond to something without needing to stitch together a score of videos or so just to actually get to a reasonable number of claims that I can look into.
And that's what I'm going to cover in this talk. Okay?
Excellent.
Agreed. That is excellent. That's what I'm here for. At least I think.
Excellent. So we'll get our distinctions on the record?
Is that some kind of Catholic thing I don't know about? Distinctions?
Let's look at the knowledge domains. I think that's
Here we go.
the first one.
Knowledge domains. Now that has to be some kind of Catholic thing. Tradcaths have their own dialect. Most of it seems designed to make you think that they're super smart and are following in the footsteps of super smart people.
Okay, one of the things that's missing in science is a firm foundation in knowing what is truth. It's called epistemology.
It's not really true that science lacks an epistemology. What is the case, though, is that it lacks an airtight epistemology that can get us to absolute certainty about knowledge. Science uses empiricism as its epistemological framework. That is to say that it uses the gathered data about observations of the real world, as well as the predictions made about such data and whether or not such predictions were vindicated or refuted, and then uses this to come up with a most likely understanding of the phenomena and principles of the universe at work. When an idea has not been falsified despite rigorous testing, and the statistical likelihood of all the experiments that confirm it just being a fluke approaches such a small value as to be negligible, then science concludes that it knows that idea to be true, while also acknowledging the small possibility that it is not true. Now, this empirical epistemological framework does have a major flaw. It simply has to assume that induction, that is, basing predictions about future events on past events, is valid. Just because something has happened in the past, it does not necessarily follow that it will happen again in the future given the same circumstances. And frankly, science doesn't even really try to address this problem. It simply accepts that induction is valid as an axiom. Because without this, there would be no way for science to actually proceed. Now, you're perfectly welcome to reject induction from your personal epistemology if you like. Just know that while you do so, you are not doing science, which again is fine. You can do all sorts of stuff that aren't science, and that's okay. Just don't pretend that you're doing science when you're really, really not.
In the first column, you see what Catholics believe. First of all, they believe in the primacy of truth coming from God himself, which is theology.
But apparently only theology from before the Second Vatican Council. So before the 1970s. Okay, sure. Of course, the Roman Catholic Church was not preaching geocentrism in the 1960s or the 1950s either, so I guess his theology-based knowledge is at least somewhat at odds with that of his own church.
And I have to distinguish here that it's pre that too that I'm talking about, because there has been some wanderings, some deviations from what Catholic belief is since, let's say, the 1960s.
It goes back way farther than that. We can see throughout the first millennium the growing claims of authority made by the Bishop of Rome, which eventually led to a split with the imperial churches of the other patriarchates in the 11th century. The doctrine of the Immaculate Conception was argued about on both sides in good faith by Catholic theologians, But then in 1854, Pope Pius IX declared it a dogma of the Church, meaning that from that point on, to be a Catholic, you had to believe it. Meaning that from that point on, many faithful Catholics that had not believed it would have been either asked to recant their beliefs or excommunicated if they were around after this declaration. Further, since this, contrary to previous declarations of new dogmas, was simply announced in a papal bull, rather than by an ecumenical council of the bishops of the Catholic Church, it had to itself be bolstered by the new doctrine of papal infallibility in 1870, which was declared by the First Vatican Council. This again was before Vatican II, and just like the ever-increasing claims of authority by the Bishop of Rome in part caused the Great Schism of 1054, between what would become the Catholic and Eastern Orthodox churches, the First Vatican Council caused the split between the Old Catholic Church and the Catholic Church that is in communion with the Pope, which includes but is not limited to the Roman Catholic Church. And this is just a sampling of the ways in which the beliefs of Catholics have changed throughout the years. So it is not just a modern post-Vatican II idea for the beliefs and teachings of the Roman Catholic Church to change. Further, given that the Pope is infallible in matters of doctrine and morals, and that the Pope accepted the Second Vatican Council, which obviously had doctrinal and moral changes, it seems like he may have done so infallibly, according to even pre-Vatican II doctrine. So I'm not sure that Robert here has an internally consistent way to object to that council.
Now, what's based on Catholic theology is a philosophy called Scholasticism.
Well, it's based on Catholic teaching as well as Aristotle,
which was a modification of Aristotle's beliefs,
which were certainly not those of the Roman Catholic Church,
to agree with Catholic beliefs. It was done by Aquinas and St. Bonaventure in the 15th century, which is the same century in which the Galileo affair took place.
While that certainly wasn't true for Augustine's participation, he was Bishop of Hippo in North Africa in the early to mid-5th century, so about 1,000 years before anything to do with Galileo. But he did establish the framework for later Christian philosophy, although he had far less influence in the Christian East, to the point where he is generally venerated as a saint in the West, but is not widely venerated in the East, and some Eastern Christians view him as a source of false teachings. I'm not here to tell you who was right about that, I'm just giving some context for this.
So we have a lot of things happening in the 15th century.
That's true.
The next source of truth.
Calling the previous things, that is, Scholasticism and theology, sources for truth is a pretty big claim, one which I think might need some backing up. But then I suppose this talk is targeted at tradcaths who already accept those things, so perhaps asking for him to justify them in this talk is being unreasonable.
Is science based on realism. Realism, as the note shows below, is a belief in objective reality. You believe in things that you see based on your senses.
Yes, and that is what science starts with, too. But as we saw with the optical and auditory illusions that I've already shown, human senses are not infallible and operate according to heuristics, which are often, but not always, accurate. And as a result, human senses cannot be relied upon with absolute certainty. Further, there are things which we know exist but cannot be directly observed with any human sense. If this were not the case, then things like radio waves would not exist, and radio would not work. Clearly, they do work. But once again, we're getting into flat Earth arguments. The Earth is flat and stationary because that's how it feels. Well, great, but science is well past a reliance on simply looking around and intuiting how one feels as a human. Further, I want to point out that while he's talking about science and realism, at no point has he mentioned hypothesis testing, the single thing that most distinguishes science from other disciplines.
And the senses are reliable as regards their proper object.
Well, we've already shown that to be false, so we've got a false premise here.
That means your eyes are reliable in seeing the world.
I want you to look at these people throwing a basketball back and forth and count how many times they do it. Okay, now tell me, how many gorillas were in that clip? Oh, you didn't notice the gorilla? Well, here's that clip again. It was there all along. Your eyes are not simply recording devices putting objective information onto a film strip that is stored in your brain without loss. Your eyes interact with your brain such that the information presented to your conscious mind is only a fraction of what your eyes take in, and even then, some things that your eyes do not take in are simply added in by your brain to fill in gaps. Another example is that both of your eyes almost always have your nose in their field of view, but you normally can't consciously see your nose. But close one eye, then the other, and look down towards the center line of your body. Your nose is right there. Your brain filters it out nearly all the time. It's simply not true that your eyes are truth detectors and see the world as it objectively is. That's why we need tools to assist us.
And they testify correctly to the mind.
I have no idea what word he just said there. If you do, please let me know.
The opposite of this would be idealism, where the world is like a dream. It's like the drama, The Matrix, where you're in a computer-generated world.
Idealism is mostly associated with Plato, and I do not think he would agree that the world is an illusion. Platonism generally simply says that the realm of ideals is more real than the physical world. Instead, the physical world is real but secondary to the world of ideals, and the way we recognize the properties of physical things is by their participation in various ideals. For example, a pufferfish is recognizable to us because it participates to some degree in the ideal of fish, sphere, spiky, etc. It participates in none of them perfectly because if it did so, it would simply be the ideal and not a physical object in the real world. But this does not mean that the pufferfish isn't real, it's just that its reality is contingent on the realm of ideals. Now, I am not a Platonist or a Neoplatonist, so I don't think this is a terribly useful way to think about metaphysics. It is also not the case that it is simply the opposite of treating reality as real, and it has little to no relation to anything I can see in science. I think it's just that since Robert here seems to dislike both idealism and science, he figures they must go together.
So we believe in objective reality, not idealism.
Says the geocentrist. It's like when flat earthers say that they only believe in observable reality, when in fact they certainly do not.
But the senses are reliable.
Except when they're not, which is surprisingly often. Here's another example. These are a series of box-shaped objects in Blender. Each of them is tilted from -2 to 2 degrees towards or away from you. Can you tell with your senses what the angles are? No, you can't, and neither can I.
We believe in causality.
What, and science doesn't care about causality? That's a huge portion of relativity just on its own, and basically all hypothesis testing requires a hypothesis that includes causality as part of it.
We believe that every effect has a cause.
Now, when you make a universal statement like that, it does invite more scrutiny. It does seem like some events may indeed be uncaused when it comes to subatomic particles. But of course, that depends on exactly what one means by cause. Is the outworking of the Heisenberg uncertainty principle causing some nuclei to spontaneously decay an example of an uncaused event? Well, nothing in particular made it happen at that particular time, so one might argue that there isn't a proximate cause. But then one could argue that there is an ultimate cause. So it turns out that while most of science has a pretty straightforward relationship with causality, it's not entirely universal. And if Robert thinks he can out-science all the physicists working on particle physics, good luck to him.
And more than that, we believe that there is sufficient cause for every effect.
Well, that's just tautological. If a cause wasn't sufficient for an effect, then it can't create that effect, and so it didn't.
That is, something cannot produce something else unless it itself has the ability to do that.
Yep.
This is called sufficient causality, or nemo dat quod non habet.
It wouldn't be a Tradcath video without some extra Latin tossed in for flavor.
That's Latin for nothing can give what it doesn't have. Then we have sequiturs and non sequiturs. Non sequiturs are contradictions.
Nope, they're just statements that don't follow. Here's an example. I left some unspun wool outside. If it rained last night, the wool will be wet. That is a sequitur. The conclusions follow from the premise. Now let's see another statement related to these. The wool is wet, therefore it rained. This is a non sequitur, but not a contradiction. It could very well be that the wool is wet because it rained, but it could also be wet from dew, from someone spraying it with a hose, or some other cause. So a non sequitur is not necessarily a contradiction.
So if something is said to be A and not A at the same time, in the same meaning, that's a non sequitur. That's a violation of the principle of non-contradiction.
Yes, it is a non sequitur, and it is also a violation of the law of non-contradiction. But while all violations of the law of non-contradiction are non sequiturs, not all non sequiturs are violations of the law of contradiction. For example, if I say some A's are B's, and X is an A, therefore X is a B, the law of non-contradiction is not violated, and yet I have a non sequitur. Since the phrase some A's are B's also entails that some A's are not B's, then simply being A is not sufficient to conclude that something is also B. Importantly, it is not even the case that the conclusion of a non sequitur even be false. For example, if I say some birds are ducks and my pet is a bird, so therefore my pet is a duck, that's an obvious non sequitur, but my pet may still be in fact a duck. It's just that you can't conclude that based on me telling you that my pet is a bird.
There are many other laws, but that's basically the foundation of realism or scholasticism.
I mean, I can get behind the law of non-contradiction as foundational to science.
Then finally, the source of truth is science, or specifically in this case, physics.
I would rather say that the source of truth is the actual physical reality, and physics is how we extract what truth we can from physical reality. At least in the areas where physics is the science that covers the phenomena under investigation, which, if you're enough of a reductionist, is, I guess, all of physical phenomena.
So notice the hierarchy. We believe in the theology first.
Yes, I did notice that your highest priority is the stuff that can't be verified or falsified. You know, the stuff in which you should have the lowest confidence.
Because the highest authority is God.
And when God comes and tells me to join the Catholic Church because it's the one true religion, then sure, I'll do that. Till then, though, I'm happy having never been a Catholic and not being one now, although I do appreciate that it was my Catholic school biology teacher that first actually presented evolution to me in a way that wasn't simply a caricature and straw man, although even he made some mistakes.
Then we go through our experience, philosophy.
I can agree with this step. You do need a philosophical framework, even if it's subconscious and you can't articulate it.
And we go through taking experiments, which is science.
Yeah, I can even agree that science is downstream of philosophy. You have to have some philosophical positions before you can get to science, like the validity of induction, as I've already stated.
Mainstream science, MS science,
Or as it's more properly known, science.
considers that physics is the pyramid of the hierarchy of truth.
Physics is a pyramid, huh? Well, that doesn't mean anything coherent. But let's say I meet Robert more than halfway and say that what he means is that science uses physics as the top of its hierarchy of knowledge, such that it is primary and all knowledge flows from physics. First, that's just blatantly wrong. Some things are tested and conclusions made in science without any physical understanding of the mechanism. For example, many drugs are used in medical science despite the way the drug actually interacts physically with the body being unknown. Further, as I've already said, science actually does depend on prior philosophical ideas, so physics is not primary in science in any meaningful way.
In mainstream science, physics is the final authority.
I feel like every single scientist who isn't a physicist might take issue with that statement, and also it feels like the kind of statement that needs a citation.
Physics, of course, is a branch of science.
That's true.
And the philosophy that underlies science is materialism.
I would argue that that is rather the methodological underlining of science, not its philosophical underlying. Scientists are not required to be materialists or to refrain from making spiritual conclusions from their work. What is not allowed is using supernatural causation in the performance of science, and for good reason. Spiritual claims are notoriously unfalsifiable and untestable, and there is no way to assess them with the tools of empiricism. So, such claims are outside the realm of science in general. Now, on the other hand, if you have a spiritual claim that is testable via empirical means, then good, go and test it. Many such claims have indeed been tested. Of course, all that, to my knowledge, have been tested publicly have been falsified.
So it excludes right from the beginning any belief in immaterial substance or spirituality.
Nope, it does not. It says that if you don't have a way to test a claim, then it's not part of science, and if you do, then go ahead and test it, but don't come crying when it's falsified.
That is the basis of modern science.
Yes, methodological naturalism is the basis for modern science, and many scientists are philosophical naturalists. But many of them are not. It turns out you don't have to be a materialist or an atheist to do science, and while such types may be overrepresented among scientists when compared to the general population, they are still not all scientists.
There is no real philosophy except materialism in mainstream science. The philosophy that they have is...
I'd argue that what philosophical basis all science has in common is empiricism, and that falsificationism is also important. But within that, there is much debate about the philosophy of science, although mostly from philosophers. The scientists are often happier just doing science rather than worrying about justifying induction to the satisfaction of some professional thinker.
Based on atheism, agnosticism, nihilism.
Man, tell it to Francis Collins, a famous scientist and founder of BioLogos, which is a ministry dedicated to showing how Christianity is compatible with science without rejecting science, as opposed to Robert here, who rejects a whole host of physics and astronomy in being a geocentrist.
In fact, if I ask some of the people I know, some of the mainstream scientists, their reaction to philosophy is, I don't need any stinking philosophy.
I will say that anyone who says that they do not need philosophy does not know what philosophy is. You don't have a choice but to have a philosophy. The question is whether you have consciously examined your philosophy or not. But no matter what, you have one. If you believe things, that is because you have a philosophy about what things warrant your belief. If you take actions to meet goals, that is because you have a philosophical framework about how the world works, which may or may not be informed by science. Everyone has a philosophy.
Right? They discount philosophy at all. And that's a contradiction because philosophy is a worldview.
No, philosophy is a field of study. Worldview are part of one's philosophy, but they're not the same thing as philosophy as a whole. I can't tell if this guy is just really sloppy with his speech, which would be weird for a philosophy buff, or if he's just really, really stupid. I mean, he's a geocentrist, so he has to be at least a bit stupid.
It's a way of looking at the world and predicting what will happen.
Well, again, many philosophies have such things, but philosophy itself is not that. And science, having a philosophy, can indeed tell you what will happen in the world if you do certain things, or otherwise make predictions.
It's your model, if you want, in your mind, of how the world works.
Yes, that's what your personal philosophy is.
So if they say they have no philosophy, well, that is a worldview. So they do have a philosophy. So right away you have a contradiction.
Okay, scientists are often wrong about what philosophy is. Since they're not really academic philosophers, I don't really care. Indeed, few scientists that I'm aware of would count themselves as people who should be consulted on philosophy. And a few of them seem to be unusually bad at it, like Richard Dawkins, who might have done more harm to the philosophy of religion than any other single person in the last millennium.
Okay, that's basically the summary.
Wow, and it was barely coherent. I feel like his actual empirical arguments for geocentrism will be, if anything, less coherent. This guy might give raw matter a run for his money.
One question with that, we look at Immanuel Kant, how he basically, I guess he postulated that we can't know anything for sure. Is that true?
Well, Immanuel Kant is the founder of modern philosophical skepticism, but he did conclude that empiricism is a means to gain knowledge about the world, but that any metaphysical conclusions could not be truly known to be true. So no, he didn't say that knowledge is entirely impossible, although some skeptic philosophers do say that.
We can't, or our senses are not reliable, maybe that's the right way to put it.
Well, that's just demonstrably the case.
Yeah, that's basically it. It's that philosophy is really nihilism, that you can't know anything.
Radical skepticism, which it should be noted is not Kant's position, is a form of nihilism, but it's not the only one. Other nihilistic ideas are that concepts such as life having some ultimate meaning, or that there is some basis for morality, are rejected. Kant was not a hard skeptic, and allowed for knowledge and even for a basis for morality. Indeed, he started one of the two biggest branches of moral philosophy, the other one being consequentialism. It would be hard to argue that he was a nihilist, especially since I suspect that Kantian moral philosophy is far closer to Robert's own moral philosophy than is consequentialism.
Atheism is that there is no God.
I agree, and I do not like the lack-theist definition that says that atheism is just not believing in God, not necessarily believing there is no God. That is a less useful definition and not the definition usually used among philosophers of religion, which is what we're discussing when we discuss atheism, agnosticism, and theism. In other words, I reject the Dawkins scale as it is demonstrably self-contradictory and betrays that Dawkins does not know what terms like theism, atheism, agnosticism, knowledge, and belief mean in philosophy.
Agnosticism is that you can't know everything.
No, that you can't know everything is just life. Agnosticism is not having a belief on the existence or non-existence of God, and hard agnosticism is believing that such knowledge is impossible, regardless of the truth of the existence of God. If you're wondering what Gnosticism is, it's a collection of religious movements centered around Jesus that generally saw the material world as corrupt and saw salvation as the shedding of materiality in favor of a purely spiritual union with God, who is usually not seen as the God who created the material world. That being, sometimes called the demiurge, was often identified with the God of the Old Testament. Obviously, this is indeed anti-Semitic, and also at odds with more or less every Christian group still in existence.
And nihilism is that you can't know anything.
Nope, that's hard skepticism. Not the same thing as nihilism.
Okay? So it's a philosophy of knowledge which contradicts itself because it says it can't know anything.
Which is itself a knowledge claim. Wow, cool, you figured it out, Bobby! Except that, of course, you can be a radical skeptic and think that knowledge is impossible, but still have beliefs, including that knowledge is impossible. Because knowledge is a subset of belief. Beliefs are just the things that you think are true, and while there are different schools of thought as to whether beliefs are simply cognitive opinions about reality or based in action, that's not really important right now. Knowledge is generally held to be beliefs that are both correct and held for justifiable reasons. So to bring back the duck and bird analogy, I might be correct that my pet is a duck, but if I think that simply because I think it is a bird, I do not know that my pet is a duck, since my reason for thinking so is not sufficient. Where skepticism comes in is in asking what reasoning could justify belief sufficiently for it to count as knowledge. For hard skeptics, the answer is none. For skeptics like Kant, the answer is that sufficient empirical evidence can do it. There are yet more epistemological frameworks that can work or not to answer that question.
And interestingly, he's the father of modern cosmology, correct?
Immanuel Kant as the father of modern cosmology? I can't find anything he wrote that I would consider cosmology, but it's not like I'm reading the collected works of Immanuel Kant for this. But I would say that Copernicus is more the father of modern cosmology, since to some degree or another, all cosmology as it exists today builds on his work. And he was the first person in the modern period that I can find to make what we might now call a scientific adjustment to the earlier ancient cosmological models.
He's the father of cosmology, they call him?
That title usually goes to Anaximander of Miletus. I've heard Edwin Hubble called the father of modern cosmology, since he was the one who discovered that the Milky Way was not the whole universe, and that in fact many of what had been identified as nebulae in the past were actually whole collections of dust, gas, and stars, just like the Milky Way. At first he called them island universes, but the term galaxy caught on instead. He was also among the first to use standard candle measurements to arrive at distances for other galaxies, as well as noticing that the farther a galaxy is away from the Milky Way, the faster it is moving away from the Milky Way. Which is also the discovery that led to the Big Bang model, since if you reverse that in time, then the farther back you go, the closer the galaxies must have been.
Well, that could be. I haven't heard that term used for Immanuel Kant, but...
Well, that's good. Robert and I are on the same page on this. Seems like our host, Gene, just doesn't know what he's talking about. And to be fair, he's a theology bro, not a history of science bro, so I guess that makes sense.
I guess it all depends on how you consider his philosophy linking to modern philosophy.
Okay.
Kant has his fans. My moral philosophy professor comes to mind as one of them. In fact, she once gave me more points than were available on a test, specifically because she really liked my short essay on Kantian moral ethics and my description of things like categorical imperatives versus hypothetical imperatives within a deontological framework. But then Kant has many detractors, and I would hazard to say that most of my audience are probably consequentialist in their moral philosophy, rather than deontological like Kant. Of course, by and large, both philosophies arrive at very similar conclusions about morality in most cases. Both of them generally prohibit murder, stealing, etc. I will say that I do think that the impossibility of interpersonal comparisons of utility is an insurmountable problem for consequentialism, and that even if it is overcome, we still have the problem of the utility monster, and so I am wary of consequentialist arguments, because I think that they start with what are probably incoherent or impossible to assess premises. Wow, I didn't really expect this to get so philosophical. It's nice to get to flex some muscles that aren't physical sciences. I do like more things than just that, you know.
All right, go ahead. So now we're on to Scripture and geocentrism.
Right.
What does the Bible say about this?
Normally, I would say, who cares? But as we saw for these guys, their basic axiom is that the Bible is true, despite the fact that the Bible contradicts itself.
So we're going to break this up into what does Scripture say about geocentrism? What does science say about geocentrism?
The Bible, at least in the Old Testament, assumes a flat earth with a dome over it in which are embedded the fixed stars. The sun and the moon travel across the inner part of the dome, and while the Bible itself doesn't really go into how they get back to their starting points to rise again, a common Hebrew belief was that there was a portal in the west and the sun went through it, then rose over the backside of the dome firmament to find a portal in the east to rise through. It also states several times that the earth cannot be moved because God fixed it in place, that animal inheritance works by sympathetic magic, that God has no power over iron chariots, and that human sacrifice to other gods can defeat God. Even Robert doesn't actually believe the Bible on most of this, unless he does, and is far, far more stupid than I had assumed.
Well, Genesis says right away there's a contradiction, because the earth was made on day 1 and the sun was made on day 4.
Yep, Genesis is not a reliable history of the world.
So heliocentrism couldn't possibly have been the model of the universe, according to Genesis.
That's true.
Geocentrism is supported by more than 30 verses, which are actually geostatic. That's what GS means.
Yep, the Bible is repeatedly wrong about basic facts about the universe. It's almost like it was written by Iron Age scribes who didn't have things like telescopes or satellites, and so they got things wrong about the universe. As I'm sure would you listening to this, if you lived in the Iron Age.
Geostatic means the earth is at rest. It doesn't move.
Yeah, I gathered that already.
And geocentrism means that the earth is the center of the universe and everything rotates around it.
Yes, I'm sure we all understand that here.
Scripture actually says in its 30 verses that the earth is geostatic.
Yes, which coupled with the observations of celestial objects moving in the sky would lead to the conclusion that everything revolves around the earth in some way, hence geocentrism.
There are no verses that say it's heliocentric. So by either direct or indirect description, we have total support for geostatism.
Yes, the Bible is indeed wrong about cosmology, like it is about biology, history, prehistory, etc.
And from now on, Gene, I'm going to call it geocentrism, and not to confuse the two, but most people are familiar with geocentrism.
Yep, and I'm not aware of anyone who thinks that the universe is geocentric, but that the Earth also moves.
So there's a verse in Scripture which says the earth is fixed on its foundation, it cannot be moved. I think it's in Proverbs.
He might think that, but it is in fact in Psalm 104, specifically in verse 5, which reads in the NRSV, "You set the earth on its foundations so that it shall never be shaken."
So there's a direct indication of the fact that the earth isn't moving. There's also verses that say the sun rises or sets, the moon rises or sets. That's another indication.
I actually disagree. I think that just like people today who aren't morons talk about sunrise and sunset despite the fact that they're not so stupid as to be flat earthers or geocentrists, are not wrong to do so, neither is the Bible. Basically, humans like to describe things as they appear to those same humans. It feels like you're standing still watching the sun move across the sky, so even though you know that that's not really what's going on, it's easy to just talk about it as if that is what's going on. I think that if the authors of the Bible had actually had a more correct view of cosmology, they would still talk about sunrise and sunset, just like we do today. After this, he just says that you can't find anything in Scripture that describes the Earth as moving, but he robots really hard and it's quite unpleasant to listen to. Not that it's Robert's fault, sometimes the tech doesn't tech. He then moves on to talking about the Ptolemaic model of the universe.
All right, the Ptolemaic model, which again was considered valid for 15 centuries because it was written by the Egyptian in the 1st century AD.
Well, more an ethnically Greek man living in Roman Egypt, but sure, whatever.
All celestial objects surround the Earth in circular orbits.
Which actually poses problems. You see, if Venus and Mercury are in orbit around Earth, and not the Sun, there should be no long-term correlation between the location of the Sun in the sky and the location of those planets. But Venus is never more than about 47 degrees from the Sun, and is usually closer, and Mercury is never more than about 28 degrees from the Sun. This means that these bodies always travel together, even though there is no mechanism for this in the Ptolemaic system, and is contra the predictions of such a system unless special pleading is used, which, of course, it is.
So if we look at the model, we see that the Earth is surrounded by first the moon, the first orbit moon, then Mercury and Venus. Now, the normal model is that Venus and Mercury orbit the sun, not the Earth.
Which should solve the problem of the limited angular distance of both from the sun. In fact, if you look at this animation of the inner solar system plus Jupiter centered on Earth, which is basically what you'd get in a geocentric universe, you can see that it really does seem like Venus and Mercury still orbit the sun. I would argue that it looks like all planets do, but hey, what do I know? I'm just a dinosaur. I bite the heads off of sauropods.
But the Ptolemaic model says that those two planets orbit the Earth.
You know, we're a far ways into this talk, and I still don't really know if Robert thinks that Mercury and Venus orbit the sun or the Earth. Although I know he thinks the sun orbits the Earth.
Then we have the sun and the planets that were known at that time. Where are the outer planets?
They were not known to exist, so they weren't in this model. But I'm sure they would have been simply placed in orbits far more distant than Saturn. But also, I want you to take a look at the geocentric animation again. We can measure the distance to the various planets. That's why in this animation, many of the planets come much closer to Earth than the Ptolemaic model could really explain. Clearly, there can't be solid crystal spheres because they would cross over each other. Despite this, the Ptolemaic model sets the planets in concentric spheres that are conceived of as solid. Now, what exactly moves the crystal spheres is not well defined, but it seems to be some kind of divine force. Of course, without them, the immediate option that comes to mind is gravity, but this is a problem. In a geocentric world, the orbital period of every single object in the universe, but Earth, is within a small margin of 24 hours. But also, everything in the universe has a slightly different orbital distance from Earth, and if orbits work by gravity, then the higher the orbit, the slower the orbit. So Earth would have to simultaneously act like it had multiple different masses, one mass value for each orbiting object. So neither gravity nor crystal spheres work. It's almost like geocentrism is wrong.
Well, remember, the telescope was just invented at this time. So these are still naked eye observations of the heavens. And that's why you don't see the outer planets.
It's at least a bit odd that he even accepts telescopes as reliable instruments, since they're some of the things that can confirm that the Earth is moving. They're the only instruments sensitive enough to detect both stellar parallax and stellar aberration. Stellar parallax is the change in the apparent position of relatively nearby stars over the course of the year as a result of different angles to them from Earth being physically in different locations. It's where we get the unit of distance called a parsec. A parsec is the distance away from Earth an object would have to be to have an annual parallax drift of 1 arcsecond, or 1/60th of a degree. Stellar aberration is the shift in the apparent position of stars toward the direction of movement of the Earth, and it is not dependent on the distance to the stars, but rather their direction relative to that of Earth's motion. There are also the cyclical red and blue shifts in the light spectra of stars that change throughout the year in line with the predicted motion of the Earth, and that is stronger the closer a star is to the ecliptic, and hence the more the Earth's velocity relative to it changes through the year. The only option geocentrism has for these is to say that for some mysterious reason, through unknown means, literally all the stars conspire during their daily orbits of the Earth and in their annual variations thereof to simply make it look like the Earth is orbiting the Sun by just happening to match all the predictions of heliocentrism. Basically, we're back to the same trickster god that just arranged all of biology to look like the outcome of an evolutionary history. The god of Christian pseudoscientists looks ever more like Loki as I look more and more into pseudoscience.
Okay, so this is what was proposed, as I said, for 15 centuries. It's simple.
It's actually not simple, and you can see that in his slide with the various epicycles that he put in there that go in all different directions. It's even less simple when you realize that they had to put epicycles inside those epicycles several times to account for error. So we have spheres inside of spheres, all of which intersect somehow to get this crazy-ass spirograph pattern of the planets. All of which is without any physical explanation in terms of forces and motion. The scientific model, though, just follows the law of gravitation and doesn't require a single object to have a complex and inexplicable epicycle. It's just gravity and perspective. Further, as pointed out, it predicted various phenomena seen in telescopes every single year that are only explainable by either God just being a gigantic liar, or the Earth orbiting the Sun.
Nothing could be simpler than putting everything that we see in a circular orbit around the Earth.
Which isn't what the Ptolemaic model does, as we can see right on his own slide.
But it's complex to compute because there are what are called deviations in that circular motion.
To me, simple and simple to compute are not really different things when it comes to science. Let me know if you disagree with me in the comments.
The conflict between geocentrism and heliocentrism.
It's like the conflict between a full-grown bodybuilder and a newborn baby.
There's a challenge given to the belief in the Bible by the Protestant Rebellion.
Sorry, but I'm not buying that the Protestant Reformation was some big cause of this, especially since Martin Luther starting that and the Galileo affair were separated by about a century, and the latter involved all Catholics. But hey, that sounds like unwelcome nuance. Also, if anything, the Protestant Reformation was about believing the Bible even harder. That's why young earth creationism is largely a creation of Protestantism, which was later absorbed into some of the far-right Catholic circles. It's also the case that the theology of most Christian flat earthers is far closer to most Protestants than it is to Catholicism. Indeed, many flat earthers blame the Catholic Church for various things to do with the supposed lie about the shape of the earth. And don't get me wrong, I'm not a big fan of the Catholic Church, but they're not the cause of all evil and misinformation in the world. Turns out that stuff is just part of being a human, Catholic or not.
Because what we had there was a personal and aliteral or non-literal interpretations of the Bible.
So, the kind of interpretation that you get all through the Church Fathers' writings, where they focus on things like typological interpretations and not so much on the literal stories. Not that they generally rejected those. This seems like a pretty straightforward outgrowth of trends in Christian theology that started way back in the middle of the first millennium, if not earlier.
And so if you allow that, then geocentrism can be challenged.
Or it can be changed if you just, don't accept that a collection of texts from the Iron Age and antiquity should be accepted as authoritative in science, which you shouldn't accept. Science is about empiricism. The Bible isn't empirical evidence of anything. So no matter if it's the Word of God, if it's inspired, etc., it's not evidence in science. You know what it is? Yeah, observations from telescopes that show the predictions of geocentrism are not borne out in real life, but that the predictions of what I'm still loosely calling heliocentrism are. And remember, I'm just using heliocentrism to mean our current understanding of the solar system, even though technically the sun isn't the center of the solar system.
According to the personal belief in whoever read the scripture, their personal interpretation.
Everyone who ever reads anything is going to have their own interpretation, because that's how the human mind works. Text is observed primarily with the eyes, although in some cases like Braille, it's a touch-based medium. This information is passed to the brain, which then interprets that text into linguistic content, and then further processes the meaning of that content. The only part of the whole process that does not happen entirely within the brain of the person doing the reading is the actual tokens that make up the text. Of course, even there, some subjectivity may creep up. In the Latin alphabet, capital I and lowercase l are often nearly identical, and so a decision as to which token is being seen must be made. Now, of course, all the interpretation steps are done in the context of the culture, biases, and prior beliefs of the person doing the interpretation. So people absolutely align their own interpretations of the Bible to things like their own interpretations of the Church Fathers. But fundamentally, it is their own interpretation. But of course, as I've said, it doesn't really matter the degree to which your interpretation of the Bible is your own, or the degree to which it is in alignment with the teachings of the Roman Catholic Church, the Church Fathers, or anyone else. The Bible isn't empirical evidence, so it's useless in answering scientific questions, except perhaps as a way for some people to decide which questions to ask.
So belief in the magisterium as the definer and translator of Scripture is a key part of understanding geocentrism.
Is it? Because geocentrism was the default assumption of nearly every pre-modern society. It seems like the magisterium just adopted it from previous Greek and Roman ideas, such as those of Aristotle and Claudius Ptolemaeus. Further, if it is actually true that the Earth is not accelerating at all, which is basically the same thing as being able to be treated as stationary, then that's a testable claim. And it's necessary for Bob's model here. Well, let's test that, or rather see if anyone has. If the Earth is spinning, that means that it is inducing a centrifugal force on everything on Earth. Centrifugal force is an apparent or fictional force. That means a force that only seems to exist in certain frames of reference. But don't let that fool you. Such forces are very real, and can affect things from continent-spanning weather systems down to single atoms. Centrifugal force is a result of applying the law of conservation of momentum in a rotating frame of reference. If an object is on or in a spinning thing, the law of conservation of momentum says that it will try to continue in the direction it is traveling. that is, tangent to the spin. But because it is prevented from doing so, it feels a force in the direction of the spin's normal vector away from the center. This fact is used in carnival rides to stick people to the sides of a spinning drum while the floor drops away, seemingly defying gravity. It is also used in medicine for things like separating the components of bodily fluids like blood by mass, since the heavier something is, the more momentum it has, and the more strongly centrifugal force acts on it, thus allowing a centrifuge to separate things by mass. This is also how things like uranium and plutonium are enriched for purposes both peaceful and bellicose. Since different isotopes of the same element have the same chemical properties, they cannot be separated by any means that relies on their chemistry. But since they are differentially affected by centrifugal force, they are spun up to separate out their isotopes. Well, if Earth is spinning, as the heliocentric model says, then the centrifugal force should be measurable. You see, the magnitude of centrifugal force is proportional to the speed of the rotation. At the poles it would be 0, since at that location all forces cancel out as you're spinning in place, meaning that your speed is 0. It should be at a maximum at the equator, since you're spinning the fastest there. In fact, at the equator, the centrifugal force should be 0.033 meters per second squared. That means that all things being equal, at the pole the force of gravity should be 9.807 meters per second squared, and at the equator it should be the same, but because centrifugal force acts perpendicular to gravity, it needs to be subtracted from that force to get the actual magnitude of the downward acceleration at the equator. As a result, the downward acceleration at the equator is about 9.774 meters per second squared. This difference can be measured on a spring scale using test masses. Because spring scales, unlike balance scales, use the force of weight of an object to measure its mass with a spring and not a balance, they are dependent on the magnitude of the downward acceleration where they are, which means that normally they have to be tared or recalculated if they are moved. Really, best practice is to tare them every time you use them, by having no objects placed on them and then setting that spring position as 0. But if you tared a scale near the equator and then brought it to the pole, and then didn't tare it again, or did the trip in the opposite direction, you'll be able to measure the effect of centrifugal force as it either lightens or makes heavier the test mass that you are using. An example of such a test was conducted by Critical Think between Australia and the South Pole during the final experiment, in which Pastor Will Duffy paid for Dave McKeegan, Austin Whitsitt, and Jaron Campanella to fly to Antarctica, and they were accompanied by Michael Toon, Lizbeth Acosta, a documentarian, the aforementioned Critical Think, and a producer from The Candace Owens Show. Specifically, they were there to test flat Earth claims, some of which are identical to geocentrist claims. And yeah, it turns out that centrifugal force is real on Earth. It depends on latitude, and the Earth really does spin. Of course, we already knew that from stellar aberration, but hey, it's nice to have that confirmed by multiple independent lines of evidence.
Now, what is the challenge to geocentrism?
Wow, sorry about that. I think the machine spirit of his Voxcaster is rebelling against this tech heresy. From weakness of mind, Omnissiah save us.
From the moment I understood the weakness of my flesh, it disgusted me. I craved the strength and certainty of steel.
Galileo's observations through the telescope contradicted the Ptolemaic model.
That's true.
They sure did.
First of all, Galileo saw Jupiter's moons.
Yes, he did, which would be hard to explain with the planets embedded in crystal spheres within spheres.
Now, the Ptolemaic model said that all the moons go around the Earth in their own orbit. This observation shows that the moons that he saw went around Jupiter, not around Earth.
I feel like we're about to find out that Robert is a Tychonian geocentrist, who believes that everything revolves around the sun except the sun, moon, and obviously Earth. The sun and moon revolve around the Earth.
So that's a contradiction with Ptolemaic model.
Yep.
The moon has phases, as we know, every 28 days. The illuminated side changes.
Well, it changes constantly, but after about 28 days, it will be back to where it was at the start of the 28-day cycle.
Venus also has phases, and those also are contradicted by the Ptolemaic model.
Mercury also has phases, but they're harder to see since it's always so close to the sun.
Mars and Jupiter, in the course of a year, sometimes stop and even go backwards.
Yeah, so do Mercury, Venus, and Saturn. I mean, really, Uranus and Neptune do too, but they weren't discovered when Ptolemaeus was kicking around, so I'm okay with ignoring them. This is retrograde motion, and it is why epicycles were invented, and also why they started multiplying into epi-epi-cycles and epi-epi-epi-cycles, and so on. Of course, the Keplerian model explains retrograde motion with simply perspective and absolutely no epicycles.
Called retrograde motion.
Hey, that's what I said. Is that a confirmed prediction? I don't know, maybe. Let me know in the comments if it's a confirmed prediction.
This is also contrary to the Ptolemy model.
Well, since the Ptolemy model doesn't agree with experiment or observation, it's wrong.
So Galileo is using the scientific method, and it is valid. These are contradictions to the Ptolemy method, which is the model of geocentrism.
He's being entirely too reasonable. I feel like there's a big old but coming.
But the question, Gene, is the error that he's finding in the geocentric theory itself or in the model that Ptolemy provided?
It's both. Now, for Galileo's time, it wasn't so clear that it was both, and a reasonable person could suggest changes to the model that could fix and keep geocentrism. But since, we've discovered things like stellar parallax, stellar aberration, the Sagnac effect, the effects of centrifugal force on the weights of object, and the Coriolis force. So there is no static Earth option that is left to us. The Earth certainly moves. The alternative is precluded by multiple independent lines of evidence.
So that's what we'll explore on the next page.
Ooh, we're finally getting into some evidence or something? That's pretty cool. Because frankly, I'm tired of philosophy and for the Bible tells me so.
All right. The Copernican model.
Okay, we talked about this, but here's the visual for it.
Hey look, a model that explains retrograde motion without any use of epicycles that have to stack one on top of the other in nearly fractal complexity. That's neat.
This should be familiar to everyone. This is the modern view of the heliocentric model.
Wrong.
First, the modern model isn't strictly heliocentric, and the stars in the modern model are not fixed. They are just at a great distance and moving in roughly the same direction as the solar system, and at about the same speed. Of course, the solar system is also known to have far more objects in it than are on screen, and further, while Copernicus assumed circular orbits, we know them to be elliptical instead. That's why no one is still using the Copernican model,
which was first proposed by Copernicus back in the 1500s.
I wonder if that's why they call it the Copernican model.
Okay, you have the sun at the center, and then all of the planets are centered on the sun, and the Earth has its moon. The other moons hadn't been seen. Mars has two, Jupiter has many, and Saturn, but they're not visible because, again, this is the 1500s, and astronomy was just in its infancy, really.
It has nothing to do with how long astronomy has been around. The problem was lens crafting and optics just not being up to the task of a good, reliable telescope with enough magnification to see the moons of Jupiter. It was lens technology advancing that made Galileo able to observe the moons which still bear his name, the Galilean moons of Io, Europa, Ganymede, and Callisto.
Now look for future notice. Look at the moon. Does the moon go around the sun?
It does not.
In this model? No. It goes around the Earth.
Yeah, that's true. I mean, it's not really true. If you trace out the path of the moon from a coordinate system fixed to the sun's position, you'll see it actually can be equally said to be in orbit of the sun, but to be perturbed in this orbit by the Earth. Both are equivalent and valid ways to describe the motion of the Earth-Moon-Sun system. Since we live on Earth and not the sun, though, it's usually easier to think of the moon going around the Earth and the Earth going around the sun.
This is claimed to be a heliocentric model, but it doesn't follow the model of Ptolemy.
Right, because it's not the model of Ptolemy, because as Robert has already stated, there are observations that cannot be reconciled with the Ptolemaic model of the universe. That's kind of the whole point of the Copernican model.
The moon would go around the sun if it followed that model.
No, Ptolemy had the moon going around the Earth too. Is he just confusing the Ptolemaic model with heliocentrism? What's going on here? Maybe he is just even more stupid than I thought.
So in this case, we have a clue to the solution of solving the Ptolemy model.
Do we? Because I think what we actually have is an example of religious extremism-induced boomer brain rot.
And that's the modern model. Even it's 500 years old.
No. The modern model of the solar system takes into account things like elliptical orbits, orbital precessions, gravity, etc. I would argue that until about 400 years ago, with Kepler's laws, we could not call any model of the universe modern, but even then Kepler still thought that what we know of as the solar system was basically the whole of the cosmos. Astronomy and cosmology have not been stagnant for 400, let alone 500 years.
Now, there's a conflict between GC and HC, obviously.
Yeah, that's kind of why we're here.
Galileo's observations contradicted Ptolemy.
They sure did, although at the time, Ptolemy still had better predictive power. Sucks to suck, Galileo. Good thing Johannes Kepler came around.
And now we consider the church's response to Galileo. What did the church say about Galileo's observations?
It varied, because even at the time, there wasn't some single consensus on all matters within the Catholic Church. Different priests, monks, bishops, etc. all had different opinions on many things. But by and large, until the Council of Trent, the Catholic Church just didn't care what astronomers got up to in terms of their models, calculations, or predictions. The idea that the Church before Galileo's time had some dogma about heliocentrism is simply not true. It's something that was mostly made up by atheist proponents of the conflict thesis of science and religion, and which has been widely adopted, but there isn't really any evidence of it. And Galileo himself was invited to lecture in front of friendly cardinals and other clergy of the Catholic Church, and himself seems to have been a sincere Catholic believer, albeit one who thought that the interpretations of some scripture passages might need to be reassessed. Further, while Cardinal Bellarmine did argue that heliocentrism was false, and thus formally heretical, that is, contrary to theological truth, but not really the kind of thing that gets you condemned as a heretic, this was novel at the time, and Bellarmine was particularly draconian in his interpretation of the decrees of the Council of Trent, which you might expect from the head of the Roman Inquisition.
Well, St. Robert Bellarmine.
Despite our Robert's odd pronunciation, he means the same Bellarmine who was the head of the Roman Inquisition during the Galileo affair.
Wrote a letter to Father Foscarini. It's a famous letter.
It should be noted that Foscarini was one of Galileo's defenders in that he agreed with Galileo that cosmology did not fall within the scope of doctrines and morals that the Council of Trent had defined as being subject only to the fathers, popes, and councils, and not open to personal interpretation. It should also be noted that this position was not particularly unusual, even if it was not the position held by Bellarmine. Also, he was canonized in 1930, and that just feels gross. But oh well.
St. Robert Bellarmine is many things. He's a defender of the faith.
By which I suspect Bob here means that he was a leading figure in the Counter-Reformation.
He's an advisor to Pope Urban.
Well, yeah, you don't get to be a head of the Inquisition without having the Pope's ear. Also, a fun fact is that the modern dicastery for the doctrine of the faith, which is a modern office in the Vatican, is a direct descendant of the Supreme Sacred Congregation of the Roman and Universal Inquisition, a governing body for the various inquisitions of the Catholic Church. So the Inquisition is still around in one form or another today, although they clearly do not have the power they did during Galileo's time.
He is a saint, obviously. He was a cardinal at that time.
I wonder how many of the saints have been heliocentrists. I would imagine basically all of the 20th century saints, and there have been plenty of those.
And he is part of the council, the Holy Office, as it's called, that will investigate the claims of Galileo.
I think Bob here is scared of calling it the Inquisition. Maybe he knows just how that institution is perceived, even within the Catholic Church.
So in this letter, what does Father St. Robert say? He's a doctor of the church, by the way.
A title which might impress Bob, but which means nothing to me, and certainly has no weight in science.
He said it's okay if heliocentrism is considered to be a computational model, but not if you consider its reality.
Not quite. He thought it was not acceptable to be believed while there were objections to it that were reasonable, and while it had not been conclusively demonstrated. Now, as a practical matter, that was the same thing at the time. But Bellarmine's position was more nuanced than simply demanding that heliocentrism be rejected because of the teachings of the Church. To a large degree, this was also the position of Foscarini and Galileo. The big difference is whether the ideas about the nature of the cosmos were properly things that were subject to personal interpretation, or whether they were to be subject to the consensus of the Church Fathers and Councils until such time that they could be conclusively demonstrated. Of course, how you're supposed to provide the evidence that would demonstrate heliocentrism if you were not supposed to believe it until it was demonstrated is a bit tricky, but somehow I don't think the guy in charge of the Roman Inquisition cared all that much. Also, maybe you can tell that me and our geocentrist friend here have very different opinions about Robert Bellarmine.
What he's saying is, if I use a slide rule or a calculator to do math, okay, well, that's using something to simplify what I could do in my head, but I'd rather do it with a simplified model, like a calculator.
Except that neither slide rules nor calculators are scientific models. They are just tools with inbuilt mathematical functions. They don't model the position, velocity, mass, or anything else of anything in the world. On the contrary, if you're basing calculations off a model involving physical positions and motions of real objects, then it's hard to see how what you're doing is a purely computational tool with no relevance to reality. Bellarmine might not have seen this, but it's hard to miss for a modern person. If your model accurately predicts reality, then that's probably because something about your model is reflective of reality, even if it is simplified, which all models are. For example, NASA uses the model VSOP-87 to figure out things like when there will be a lunar or solar eclipse, when there will be transits of planets by moons, or the Sun by Venus or Mercury. The way it works is by actually modeling the physical positions of these bodies, their masses, their velocities, and their gravitational interactions. It is hard to imagine how this could work so well if it wasn't in some way reflective of reality.
Well, the same thing holds for heliocentrism. Copernicus' model can be used if you consider that it's not the true model of the universe, but it's helpful in understanding how the cosmos moves.
I would love to know how Bob thinks that a model that is not reflective of reality in any way can actually be so useful that it can be used to calculate the locations, dates, and times of solar eclipses thousands of years in advance. I'd ask Bellarmine, but my understanding is that he's not available for comment.
Number 2, the magisterium and the fathers demand a literal interpretation.
They don't, and I can't find anything from Bellarmine indicating this. But hey, I'm not reading everything he ever wrote for this, since fundamentally, what Bellarmine says doesn't really matter. Also, remember when I thought we'd be getting into some actual empirical evidence, or at least claims? How naive I was. Of course, I bet that if Bob thought that he had actual empirical evidence, he'd have led with that, since that would be convincing even to non-Catholics, although I suspect this is also not very convincing to most Catholics. If you're Catholic and you feel comfortable disclosing that, let me know if you find his theology compelling. But further, the idea of the two books, Scripture and Nature, being the source of doctrine is a very, very old one, and reinterpreting Scripture in the light of the Book of Nature goes way back. Doing that is the very reason the Catholic Church never taught the earth as flat, even though a literal reading of the Bible demands such a belief.
So if we deny that the 30 verses are true, which say that the earth is at rest, then that denial would deny basically all of it.
I disagree, but I also don't really care. If you as a person need the Bible to be literally true in all of its passages, and if it's not, then you feel compelled to abandon it, then I have bad news for you. You should abandon the Bible. Or you could just have a non-literalist interpretive framework. I don't know, I'm not your pastor, priest, bishop, or even inquisitor.
One way of putting it would be, it's letting the camel's nose under the tent, which is the way they used to say that you're letting in error get into the body of truth.
That's not the point of the saying. The point is that with some things, you cannot let even a little of them in or the whole thing will follow. It doesn't even technically require that the camel be analogous for something false. For example, I could argue that once creationists accepted speciation, they more or less the camel's nose into the tent, and they have ever since been slowly accepting more and more science, that is, the camel. Similarly, when Americans decided that it was okay to just vote for a rapist, they let the whole of sexual abuse and pedophilia protection become the official policy of the GOP, or Guardians of Pedophiles. This is fairly minor, but it goes to show that Robert really doesn't care much about being right, just thinking that he's right.
The third thing that Bellarmine said was, if heliocentrism was true...
Which, strictly speaking, it's not, but it's much closer to true than geocentrism.
Then the biblical meaning has been misunderstood. That is, what we read is not what the Bible meant.
Personally, I think it just means that the authors of the biblical text were in error, but hey, if you want to, feel free to reinterpret the meaning of the Bible. It's not like that wasn't already going on at the time and hadn't been for millennia already, before there even was a collection of works called the Bible. That's something I wish more people would appreciate. No one, not the Catholic Church, not Protestants, not the Eastern Orthodox Church, not the Mormons, not the Jehovah's Witnesses, not atheists, comes to the Bible and just doesn't interpret it, usually in ways that were not intended by the authors. We simply live in a different world than the one that existed when the various texts that now make up the Bible were written, edited, and compiled.
And that's certainly possible, because we're human.
I'm actually surprised he admitted to that possibility.
However, Bellarmine points out, no one has shown that heliocentrism is true.
At that time, that was correct. It is not that time. It has been shown time and time again in the intervening years between now and then.
The relative motions between all of the objects in the cosmos show that either GC or HC could be true.
No, in fact, geocentrism violates the laws of relativity in a fundamental way, and even violates basic Newtonian mechanics. Let's take the stars that are at extreme latitudes, either south or north. We will select the so-called pole stars, Polaris and Sigma Octantis. Polaris is about half a degree from the north celestial pole, and Sigma Octantis is about a whole degree from the southern celestial pole. That means that each day they trace tiny circles around their respective celestial poles. Now, we know from spectroscopy that both are indeed stars burning through hydrogen in nuclear fusion much the same way that the Sun is. So we know that they are massive balls of plasma. Now, in an orbit, the orbiting body always circles around the mutual center of mass of the system, which in the case of geocentrism would apparently be inside Earth, since everything goes around the Earth. But the problem is that these stars do not do this. Neither do any stars not directly on the celestial equator. But the problem is most pronounced for these two stars. What force could possibly keep a star nearly 250 light years away in the case of Sigma Octantis, or 430 years away in the case of Polaris, circling in a tight little circle centered on some arbitrary point above the north or south pole of Earth, rather than circling around the Earth itself? When the fixed stars were thought of as embedded in a crystal sphere and all equidistant, with the sphere itself rotating, this made more sense. Obviously, if you're set in the surface of a rotating sphere, then your center of motion will only be the center of the sphere if you're on its equator, and those stars aren't. But we know that these stars are at various distances. Further, of course, this motion for the stars near the equator would have to be many times the speed of light, which is a violation of relativity. So stars at the equator have a relativity problem, and stars at the poles have an orbital mechanics problem, and all the stars really have both in proportion to their latitude. So there really are no stars for which geocentrism works.
Either one could be true, because it's only relative motions between them that are measured.
Wrong.
In fact, acceleration is measured as is the motion of the Earth relative to the stars via stellar aberration. In Galileo's time, this was true, but it's very untrue now.
It's Holy Writ that says that it's only geocentrism that represents reality.
So it's only something that isn't in any way evidence in science that says that geocentrism is reality. Fair enough, but that seems like a good reason to reject geocentrism, or at least not think it's a serious contender among the options for cosmology.
So if you have a ship and a ship passing along the shore, if you're on the ship, you can have the apparent belief that the shore is moving.
And if the ship's not accelerating, that belief is physically valid. But if it is accelerating, then no, you can't maintain that belief. The Earth experiences acceleration, which means objectively it is moving. It is not a purely inertial reference frame, which is the only kind of reference frame that can be said to be motionless under any circumstances. Motion is relative, but acceleration is not.
Because that's what you'll measure.
All right, guys. Sometimes you are wrong in life.
Okay, but we know that the true motion is relative to the shore, not relative to the ship.
No, we don't. That's a convention. If the ship is truly not accelerating, which is unlikely in the real world, but perfectly fine in hypothetical land, then there really is no difference between the ship being still and the shore moving past it, and the ship moving past the shore.
And the Bible says that what we see from Earth is reality.
Well, yeah, but that's because the authors of the biblical texts didn't have access to things like precise timepieces, telescopes, accelerometers, etc. You know, the things we use to actually figure out if the Earth is moving or not. They can't be blamed for living when they did. We all live when we do, and we are all subject to the prejudices and limitations that come with that. But to then pretend that they did not have such prejudices and limitations and were instead perfectly accurate about all things is to simply delude oneself. And as I've already pointed out, there are plenty of things that the Bible says that I doubt Bob would agree with. Like, I don't think that he thinks that breeding livestock in front of stripy sticks mean that they will have stripy offspring. I bet he acknowledges that DNA is the molecule of inheritance, But if the Bible is to be taken at face value, then that's simply not true. Now, I think Bob would say that the naive interpretation of that is wrong, and that's fine. But he can also do that about the 30 verses that he interprets as indicating a non-moving Earth. I'm honestly not sure why tradcath geocentrists choose this as a hill to die on. This is probably because, never having been a Catholic, I'm not really familiar with the extremes of Catholicism like I am with Protestant Christianity.
You should insert the word "from earth" in there. Bible says what we see
From Earth is real.
is
So the observations of space probes and robotic rovers from Earth aren't reality. Why not? Why does reality cease being real when observed away from Earth? Is there some mystical limit to reality? Where once you're a certain height above Earth, reality just isn't real anymore? Are we living in the Matrix and the Earth server has physical limits and anything past that has to be shunted to the space server where the simulation is different, but somehow lines up with heliocentrism, while also relaying information back to the Earth server that is geocentric?
Okay. And now some of the things you hear from people nowadays is you hear there's a literal translation of the Bible and literalistic. Is that just an excuse people use to kind of make up their own thing?
Well, it's an interpretation, not translation. But yeah, people vary in how literal they want to be with the text. And you have to be, because the text is internally contradictory. So if you want it to be true at all, you will have to say that some of the contradictory statements don't mean what they seem to mean when taken literally. Further, some bits of the text directly contradict what we know from our own experience and science. So again, if you want to maintain that those aspects of the text are true, you'll need to find another interpretation other than the literal meaning of the text.
That's how I've heard it explained, that if you were especially relating to Genesis and the flood and creation.
Looks like our boy Gene Zanetti is also a young Earth creationist. That's hardly surprising, since if you're going to be even more wrong than most of them about the nature of the universe, you might as well be similarly wrong about the age of the universe and biology and hydrology, and optics, and particle physics, and geology, and thermodynamics, etc.
That if the Bible says it's raining cats and dogs, it's not literalistically raining cats and dogs. The literal meaning is what's the author trying to convey. So is that just opening up the door for the camel to stick its nose under the tent?
Only if the camel here represents being even possibly right about anything while maintaining the Bible is right about everything it talks about.
Yes, basically, the resolution of all these things is the verse we're looking at an analog? Is it has a spiritual meaning, not a physical meaning, etc.? All of this, when there are issues involving interpretation, should be resolved by the magisterium.
Well, the magisterium currently seems to not say that the Earth is the center of the universe. Or did the magisterium simply die out at the end of the 15th century or something?
That is the ultimate authority.
And the magisterium is, according to Catholic teaching, especially expressed in the bishops with the Pope supreme among them. How many of them are geocentrists? I would suggest that whatever the number is, it almost certainly rounds down to 0.
You use the word literalistic. I'm not familiar with that. Literal means to take the words as they normally mean, and not try to extend them to areas where they don't belong.
But some things are normally figurative. If you say, no, I can't hang out today, I have too much on my plate, the normal meaning of that is that I have a lot to do and am busy, not that I literally have a large amount of stuff, presumably food, on an actual plate that I now have to deal with, presumably by eating it. Literal is simply the opposite of figurative. It means taking words at their most basic meaning, usually regardless of context.
Okay, and then one other thing I heard from the Thomistic evolution guys, there's a group of Dominican priests, seems like they're well-meaning. They try to push evolution and saying that it's in line with Scripture.
Something more than one pope has agreed with.
One of the big hinge points for their argument is they say Genesis 1 and Genesis 2 have a slightly different order of creation.
I'd say it's very different. But whatever, they're definitely different, especially if you take them literally. In fact, I would argue that it is impossible to take all of Genesis 1 through 3 literally at the same time.
It's men, then animals, then women.
Actually, it's men, then animals and plants, then women.
And then the other chapter, it says, I guess, animals, then men, then women, something along those lines.
Nope, the order in Genesis 1 is plants, then animals, then men and women together.
And they hinge their argument saying, if the order is different, then clearly it's not to be taken literal. Otherwise, we have a contradiction, and the Word of God can't contradict itself, so therefore, this must be symbolic. How do we respond to that?
I would suggest just being honest that, yeah, the Bible contradicts itself here, and that all evidence suggests that neither story is literally true. But that's just me. Oh, and also most seminary professors.
Well, it's interesting that you should bring that up, because that is a future topic, which would fill which would fill an hour. But
would that hour be full of evidence or just philosophical meanderings that aren't even good philosophy? I'm guessing the later, just like this topic so far.
Give you the quick and dirty resolution from, in my humble opinion. Okay.
Uh-oh. We're about to get private interpretation of Scripture from someone without the teaching authority of the episcopacy. Seems like something Robert Bellarmine would disapprove of.
If you apply the scholastic concept of hylomorphism to Genesis, which means that reality is created by the activation of different forms, or forms acting on prime matter.
Sounds a lot like the idealism he earlier complained about. He wouldn't be about to be hypocritical now, would he?
Okay. Prime matter is matter without any characteristics.
So no volume or mass? Okay, but that's not matter, since matter is basically defined by taking up space and having mass. So in what way is this matter at all? This seems like something that was just thought up by someone who didn't know any physics, and of course, that's exactly what this is. It's also why transubstantiation doesn't even make sense until you know about the Aristotelian distinction between substance and accident, which bears no relation to how we know the world actually works. Which might be why no other Christian groups, even those like the Eastern Orthodox who believe in a Eucharistic miracle and real presence, accept transubstantiation. They're not married to Aristotle like the Catholic Church seems to be, even though I think they're supposed to be married to Christ.
All right, so think of the matter as being a blob, which has no color, nothing that you can sense.
Then it wouldn't be a blob, because that describes an irregular rounded shape, something that can be sensed.
Until it is informed by a form, a substantial form.
So what was this made of? Electrons, protons, neutrons, muons? What? Physically, what was it made of? Because any answer is going to result in something with properties. Also, this interpretation is straying pretty far away from what you typically get with ex nihilo creation, in which the matter is not pre-existing. Now, I'd argue that Genesis does not describe creation ex nihilo, but whatever. That's the idea of creation that Christians have almost universally adopted, although the Mormons reject it.
And consider that Scripture is describing, in the first day, the creation of forms.
Is it? It seems like it's describing the creation of things, like the sun and moon, and stars also, or the creeping things and beasts of the fields, and every green herb and plant, and the fish of the sea and the birds of the air. It's not really ambiguous, but just like I said, you can't just take the Bible at face value. Even Bob isn't doing that. He's making up stuff about Genesis 1 in an attempt to conform it to both Genesis 2 and his own philosophy informed by Catholic teachings, which are themselves informed by Aristotle as much as by Jerusalem.
Okay, that is the models for all future species, man included, all the animals, the plants, and everything else, first are created in a model.
Something we should see somewhere in Genesis 1, right? The word model or something to indicate it? Well, let's check. Here's Genesis 1 from the Douay-Rheims translation, since Bob is a Catholic.
In the beginning God created the heaven and the earth was void and empty, and the darkness was upon the face of the deep, and the Spirit of God moved over the waters. And God said, Be light made, and light was made. And God saw that it was good, and he divided the light from the darkness, and he called the light day, and the darkness night, and there was evening and morning, one day. And God said, Let there be a firmament made amidst the waters, and let it divide the waters from the waters. And God made a firmament, and divided the waters that were under the firmament from those that were above the firmament, and it was so. And God called the firmament heaven, and the evening and morning were the second day. God also said, Let the waters that are under the heaven be gathered together into one place, and let dry land appear. And it was so done. And God called the dry land earth, and gathering together the waters he called seas. And God saw that it was good. And he said, let the earth bring forth the green herb, and such as may seed, and the fruit tree yielding fruit after its kind, which may have seed in itself upon the earth. And it was so done. And the earth brought forth the green herb, and such as yieldeth seed according to its kind, and the tree that beareth fruit, having seed each one according to its kind. And God saw that it was good. And the evening and the morning were the third day. And God said, let there be lights made in the firmament of heaven, to divide the day and the night, and let them be for signs, and for seasons, and for days and years, to shine in the firmament of heaven, and to give light upon the earth. And it was so done. And God made 2 great lights, a greater light to rule the day, and a lesser light to rule the night, and the stars. And he set them in the firmament of heaven to shine upon the earth, and to rule the day and the night, and to divide the light and the darkness. And God saw that it was good. And the evening and the morning were the 4th day. God also said, let the waters bring forth the creeping creatures having life, and the fowl that may fly over the earth under the firmament of heaven. And God created the great whales and every living and moving creature, which the waters brought forth according to their kinds, and every winged fowl according to its kind. And God saw that it was good. And he blessed them, saying, increase and multiply, and fill the waters of the sea, and let the birds be multiplied upon the earth. And the evening and morning were the 5th day. And God said, let the earth bring forth a living creature in its kind, cattle and creeping things, and beasts of the earth according to their kinds. And it was so done. And God made the beasts of the earth according to their kinds, and cattle, and everything that creepeth on the earth after its kind. And God saw that it was good. And he said, let us make man to our image and likeness, and let him have dominion over the fishes of the sea, and the fowls of the air, and the beasts, and the whole earth, and every creeping creature that moveth upon the earth. And God created man to his own image. To the image of God he created him, male and female he created them. And God blessed them, saying, increase and multiply, and fill the earth, and subdue it, and rule over the fishes of the sea, and the fowls of the air, and all living creatures that move upon the earth. And God said, behold, I have given you every herb bearing seed upon the earth, and all trees that have in themselves seed of their own kind, to be your meat. And to all beasts of the earth, and to every fowl of the air, and to all that move upon the earth, and wherein there is life, that they may have to feed upon. And it was so done. And God saw all the things that he had made, and they were very good. And the evening and the morning were the 6th day.
Wow, it's almost like there was absolutely nothing in there that even hinted that what was being created was just models. It's a self-contained creation story that has the creation of basically everything an Iron Age Near Easterner would have known about. And hey, it also contradicts Genesis 2.
Which is a description of what they will be. What are their characteristics or their qualities?
Except that it doesn't describe that. It has God speaking light into existence, and then organizing a pre-existing earth into land and sea, and then commanding the land and sea to bring forth living things, which they then do. And then abruptly, after the start of Genesis 2, we get a brand new story, in which at least some of that previous stuff has not happened.
On the 2nd day, we have a description of the activation of those forms.
No, on the 2nd day, God puts a big dome over the flat earth and then separates the land from the waters. And the big dome is to keep the waters of the cosmic ocean above the earth out. He doesn't activate anything unless maybe it's the ability to not drown. Did he perhaps mean the 2nd chapter? Because there's nothing in there about activating some dormant design. That's just made up. And look, Bob is allowed to make stuff up. But what he's not allowed to do is to then pretend that what he made up comes from the text and not him.
Into the actual creation of the plants, the animals, and so on, up to the 6th day of man. So there's no contradiction.
Yeah, there's no contradiction if you just make up wild shit that isn't anywhere in the text and wouldn't even be recognizable to anyone within 100 years of its composition. You know what a contradiction is called when it's solved by just making up shit that isn't actually anywhere in the text? Yeah, it's called a contradiction. The Bible contradicts itself, and attempts to prove otherwise rely on completely wild speculation about stuff that's nowhere in evidence. Although I'll admit, some alleged instances of contradictions are weak in my opinion. But that's far from all of them.
We have creation occurring in steps. First, the creation of forms, and then the forms do not create new things, because creation refers specifically to going from nothing to something.
Well, that's not what the text has in either case. We've already addressed the forms. But I'm going to play a bit of Dan McClellan on creation ex nihilo, since I'm no Hebraist.
Hey everybody, the concept of creation ex nihilo, or out of nothing, is post-biblical. It's not found anywhere in the Bible. Now, two texts that are frequently cited from the Bible as being direct indications of creation out of nothing are Genesis 1:1 and 2 Maccabees 7:28. Neither of these actually promotes that idea of creation out of nothing. The scholarly consensus regarding Genesis 1, the whole chapter, not just the first verse, is that it points to creation out of existing material. And that holds even if we accept the traditional rendering of Genesis 1:1 as in the beginning, God created the heavens and the earth. Now, a more likely rendering that does away with some of the grammatical problems is when God began to create the heavens and the earth was tohu vabohu. In other words, it does not have a recognizable form or function, but it is materially there. And the verse is just referring to the state of the earth and the heavens when the creation of their form and function as we recognize them today, or at least as they recognize them in the time period in which Genesis 1 was written.
By the way, Dan McClellan is a great communicator of biblical scholarship who strives to make the academic consensus on various topics about the Bible accessible to the public, as well as explaining why it's the consensus, even when he personally disagrees with that consensus. I left a link to his channel in the description, and you really should check it out, unless I didn't do that because I'm bad at my job. If I didn't, tell me in the comments so I can add it.
That's creation.
As reinterpreted by Bob, and certainly not as it's portrayed in the Bible.
When you go from one form to another, or one being to another, that's change.
Sure, that's change. No argument here.
And that's explained by hylomorphism.
Hylomorphism? What on the Omnisci's red Mars is hylomorphism?
I aspired to the purity of the blessed machine.
Am I mishearing him? Is this a new word? Does he mean holomorphism? Like in a holomorphic function, which is a mathematical concept that can be used to transform shapes and is indeed a concept in the evolution of the morphology of organisms? I've also used such techniques to animate an ontogenetic sequence from a juvenile animal to an adult. That would kind of make sense in this context, but I'm also not sure what the point is. If that's what he's going for, then he's simply wrong that all evolutionary change is holomorphic. Holomorphy really only explains change between very closely related species, and even then, only imperfectly. It also has absolutely no relation to molecular evolution, which is fundamentally not well described with holomorphic functions, but rather is better described with information theory. Even though when we do that, creationists complain that that's not what they mean by information.
So what I'm saying is the first day is the creation of forms in the scholastic model, and the second day is the creation, the direct creation, or the change rather, from the form to the instantiation, to the I keep saying change, instantiation of the explain all of the people who were existing after Adam and Eve. They came from the forms that were created on the first day.
Yeah, sure, whatever. We can just make up whatever metaphysical bullshit we want anytime there's a contradiction. You know what that is? That's just wallowing in your own belief bias and being completely unwilling to actually assess claims and evidence. No wonder this guy's a geocentrist. Excellent.
Okay, excellent.
That was a giant pile of hot steaming bullshit fresh from the bowl that explained nothing and just butchered the text. How was that excellent? Do these two just hate the Bible? I think most atheists I know have more respect for the Bible than these two doofuses.
Not the first day, the first chapter of Genesis.
Right.
Yeah, I thought that's what he meant. That at least makes this comprehensible, even if it keeps it absurdly stupid and very obviously a desperate attempt to cover over a contradiction with a philosophical framework that neither the author nor his audience would have ever heard of, and that clearly is not even hinted at in the text.
Right. Okay, excellent. So we'll moving on along. Einstein. Let's hear about Einstein.
I'm taking bets on how long this goes before it gets deeply anti-Semitic. It's not like tradcats are known for their love of the Jews.
Okay, Einstein we'll talk about later. Relativity says that either the ship or the shore can be measured at rest.
As long as neither is accelerating. That's important. If one of them is accelerating, then we cannot treat it as if it were at rest.
So you could take either point of view, okay? So Einstein would agree with, well, he would disagree with anyone who says heliocentric or geocentric, right?
Wrong. Extremely, very obviously wrong. That couldn't be farther from the truth, because fundamentally we contest those ideas. In fact, geocentrism would require multiple violations of relativity because it requires most of the objects in the universe to be moving many times the speed of light, something that is impossible in relativity. So no, he wouldn't say that you can't pick either. The fact that the motion of inertial reference frames is relative doesn't mean anything can be anything, and nothing can be said to spin around anything, and it's all whatever we want it to be. Relativity sets up spacetime as the background on which events occur, and it has an absolute speed limit for causality. The distance in spacetime between any two events is the same for all observers, and the speed of the propagation of light is also the same for all observers. And it cannot be exceeded by anything moving in spacetime. Therefore, geocentrism is wrong. End of story. There are galaxies we know of that are 10 billion light years away. That means that a galaxy at that distance and near the celestial equator has to make an orbit of about 63 billion light years in a single day. That means that the galaxy is moving at 23 trillion times the speed of light. If you think Einstein would just say, yeah, sure, seems reasonable, then you don't know anything about Einstein.
Because geocentric, you're saying only the Earth can be used for measuring. No,
it's saying that the Earth does not accelerate, and instead everything else accelerates around it. That's not the same thing at all, and it's measurable. We can measure the acceleration of Earth, and we can also measure the motion of other bodies. Our measurements are completely incompatible with geocentrism, and nothing about relativity says that all reference frames are the same. That is a misinterpretation of general relativity, which says that all inertial reference frames are equal. That is, all reference frames not under acceleration. The Earth is not a truly inertial reference frame.
And those who say heliocentric, same thing. They're saying only the sun can be used.
But those people are the ones that have actual measurements in their favor. And let's remember, we're now 2/3 of the way through this interview, and we don't have a single measurement that even purports to support geocentrism. And further, no, that's not what's being done. You can use whatever coordinate system you want, and the sun isn't even the actual center of the solar system. Nor does heliocentrism, in the broad sense, in any way discount that moons work. This is apparently just an argument that choice of coordinate system changes reality. It doesn't. Coordinate systems are chosen for convenience. For example, on a world map, latitude and longitude are used, and you can use distance from the center of the Earth to depict the heights of objects. But if we were to use that coordinate system, which can define any point in space with perfect accuracy, to point out where, say, Olympus Mons on Mars is, we would quickly find out that it's a super inconvenient system. The location would be changing constantly. On the other hand, if we use a latitude and longitude system on Mars, then the location of Olympus Mons is fixed, but the location of, say, Mount Everest is now constantly changing, whereas before it was fixed. Even outside of astronomy, you can see this in everyday life. Humans tend to orient themselves in numerous ways. You might know that the grocery store is west of you, and maybe your local house of worship is to the southeast. But on the other hand, when you're describing to a guest where to find the bowls in your kitchen, you probably use a relative coordinate system, like left of the cabinet with the glass face and cups in it. Left shifts with the observer, and the left, right, forward, back coordinate system doesn't map onto the north, south, east, west system. Yet we use both just fine. What matters is that the Earth is measured to move in relation to itself by turning and in relation to the sun and background stars through its orbit.
So Einstein contradicts both of them by saying, in relativity, either one can be used. You can measure motion if you're on the ship or you're on shore.
Einstein in no way contradicts heliocentrism because this guy just doesn't know what he's talking about. All motion is relative, that's true, but that does not mean that geocentrism is just as valid. Because geocentrism and heliocentrism both involve non-inertial reference frames, and non-inertial reference frames cannot be treated as at rest in relativity. And which objects are or are not in inertial reference frames differs between the two. Which means that yes, there are in fact measurements that can be used to determine which is right. And as I mentioned last time, we've done those measurements, and it turns out that no, the Earth is not an inertial reference frame. And therefore it cannot be treated as if it were at rest under all circumstances. Now, of course, for some purposes, it's fine to treat it as if it were at rest, like when planning a hike or navigating across the ocean. That's because all the effects of motion are so small that they're far smaller than the level of tolerable error in such endeavors. Treating the Earth as moving when you're driving to the store would be far more complicated, and the difference in your predictions about how to get to the store would be in micrometers, which, given that you can't drive that precisely, would be completely irrelevant. So we use an Earth-fixed coordinate system for that. This guy is just doing that thing that flirfs always accuse normal people of doing, reifying a model. He's suggesting that which model of Earth we use actually changes what we think the Earth really is like.
Now, what is Bellarmine's point? Well, if we doubt the validity of something so fundamental like geocentrism.
I don't think geocentrism is fundamental. To me, the only properly fundamental beliefs are those which cannot be demonstrated and yet which are vital to any other intellectual pursuits. Things like that oneself exists, that the senses are detecting an objective reality, that reality operates according to consistent rules, and that those rules are discoverable. Those are fundamental beliefs to me. I can't really show them to be true without circular reasoning, and yet I need them to be true to interact with the world in a meaningful manner, and so I simply accept them. Also, they just kind of feel true, which isn't necessary, but it helps. Geocentrism, though, is dependent on these things. Like, let's propose a hypothetical. Let's say we come to a planet full of blind aliens who dwell their whole lives in caves. None of them have ever seen anything, and none of them know that stars exist or even that clouds exist. They would have no concept of either heliocentrism or geocentrism for their world. And if you ask them if their world was the center, they might not even have a conception of what it might be the center of. So the idea of geocentrism isn't fundamental, it depends on other fundamentals, like the general reliability of observation, the existence of an external reality, and the ability to even perceive that things in the sky exist in the first place. Geocentrism is a contingent belief, and before anyone comments about it, I know that in another star system we'd need new names besides heliocentrism and geocentrism, since those are specific to Earth and Sol. I don't care to come up with such terms.
I mean, it's clear that that's what the whole book of Scripture describes.
And it's wrong about that, just like it's wrong to imply a flat Earth in Genesis 1, Psalm 104, and Isaiah 40. By the way, if you're one of those types who prefer the Septuagint numbering of the Psalms, then it's Psalm 103.
How could it be unreasonable to then doubt it all? Okay, if we let one thing, one part of it, Scripture be an error, then all of it could possibly be an error.
Yup, and all of it could be an error. Now, that's not likely, as at least some things in the Bible are corroborated to some extent, and we know from a strictly literal standpoint at least some of it must be an error since the Bible isn't internally consistent. The only way forward is to simply acknowledge these simple and irrefutable facts about the books that make up the Bible. They're frequently in error about history and science and often in conflict with each other. Does that make God not real? No. Does it mean the Bible should play no part in your religious tradition? No. Does it mean you're going to need to do more than just read the Bible in order to figure out how the world works? Yes. Does it mean that when you're doing science, the Bible is completely useless? Also yes. If acknowledging that makes you decide that you can't be a Christian, or more specifically a Catholic, then oh well, you should probably just stop being one. If it doesn't, and you can maintain your religious affiliation, then good for you.
So at the Holy Office trial, Galileo was suspected of heresy. Okay? Suspected of heresy. So at that time, it's clear that if you believed in heliocentrism, you were a heretic.
It was not, in fact, clear. In fact, it was the controversial view of Robert Bellarmine that heliocentrism was a formal heresy. But that was far from the universal view, and the fact that Galileo was known to give lectures on heliocentrism to friendly high-ranking clergy, such as cardinals and other bishops, should probably give the lie to the idea that it was just generally considered heretical to accept heliocentrism.
Or at least suspected of being one.
Given that who counts as a heretic changes in the Catholic Church from decade to decade, I don't really care, and given that I'm not a Catholic, I care even less.
Now, what did the office say? They said that the sun is in the center of the world and immovable is an absurd concept, philosophically false, and formally heretical.
That's from the letter of Robert Bellarmine to Foscaridi, not the proceedings of the inquisitorial trial.
So if you believe in heliocentrism, you are a formal heretic.
Well, maybe you'd have been declared so in Galileo's time, but times have changed. In 1758, heliocentrism was dropped as a cause for books to be on the Index of Forbidden Books, which, yes, is as dystopian a thing to have as it sounds, and while I would say that the Catholic Church's response to the whole affair have been underwhelming at best, especially in recent years, since virtually all Catholics today, including bishops, are heliocentrists, I don't think you can actually reasonably make the case that the actual position of virtually every cleric in the Catholic Church is heresy in the Catholic Church. Now, if you're part of some other church, then you might think that things that the Catholic Church teaches are heresy anyway, like Protestants who tend to see the cult of saints as heretical, or the Eastern Orthodox who tend to see papal supremacy, which is distinct from their own doctrine of papal primacy, as heretical. It's almost like heresy is in the eye of the beholder.
They didn't say the same thing about saying that the earth is not the center of the world. That is, denying that the earth is that the world is geocentric, or that it's geostatic.
Yeah, because just like today, the belief of nearly every Catholic is heliocentric, at that time, the belief of nearly every Catholic was geocentric. Religions tend not to declare their own ideas heretical when they have nearly universal assent. I'm not expecting Protestants to start calling the perspicuity of scriptures heretical anytime soon, even though it's self-evidently absurd.
They said that that's absurd, philosophically false, and erroneous in faith, okay?
Well, okay, if by they he just means Bellarmine and his allies. We know that wasn't the position of the whole Catholic Church, whether we mean the whole church militant, just the clergy, or even just the episcopacy.
But not necessarily heretical. So they made a distinction there.
How kind of them. Also, remember how we were supposed to talk about Einstein, and then we just never really did, except for Bob not understanding general relativity at the most basic level? Instead, we're just back to the Galileo affair. But here's the thing. No matter what happened between Galileo, Robert Bellarmine, and the Catholic Church at large, that has no bearing on the way the universe or solar system works. And it's for the same reason that nothing the Bible says matters to this question. The proclamations of the Catholic Church aren't empirical evidence, no matter how true or false they may be, and no matter how much the Bishop of Rome may or may not be the vicar of Christ and king of his own little kingdom. When it comes to astronomy, as all sciences, it's data or get the fuck out.
Okay, let's look at the contest between the two centrisms from the scientific side.
Also known as the side that matters.
Almost 20 to 30 years after Copernicus produced his model, an astronomer named Tycho Brahe produced the Tychonian model. And what that consisted of was a hierarchy of views, which shows the planets orbiting the sun, but the sun itself orbiting the Earth.
It has the advantage of not needing epicycles, and explaining the fact that the locations of Venus and Mercury are always within a certain range of the Sun, unlike Mars, Jupiter, and Saturn, who can be up to 180 degrees away from the Sun. It had its own problems, though, in that it cannot explain stellar aberrations, stellar parallax, Coriolis, or the measured effects of centrifugal force, or, now that I think about it, Foucault's pendulum. The latter one is an interesting one, because it's often repeated, and many people live near a museum that is more or less constantly running such a pendulum. Foucault's pendulum is unlike a pendulum in a grandfather clock, because it is free to swing in any direction, not constrained to a single axis. The pendulum needs to be heavy and have a very long arm, and be isolated from things that may affect the direction of swing, like wind. When properly isolated, the direction of the swing will drift over time in a relationship related to the sign of the latitude of the pendulum, such that at the poles the pendulum will rotate at 15 degrees per hour, and at the equator it will not rotate at all. The direction of the rotation will swap between the North and the South Pole. This behavior only makes sense if the Earth is rotating around its axis. There is no stationary Earth explanation for this phenomenon that has been put forth that I'm aware of. So, sorry Tycho, but your model doesn't work, although it's better than the Aristotelian model.
In fact, the first level, as it's called, is the sun and moon and stars orbit the Earth, which is shown in the diagram.
Well, the stars aren't in the diagram, but whatever.
Then the second level is the planets and comets and asteroids orbit the sun. And then in the third level, the moons orbit the planets.
Of course, none of this can fit into physics, since that's not how gravity works at all. But hey, what's a few physical impossibilities between friends, right?
So it's called a hierarchical or leveled model. And we saw that, didn't we, in the Copernicus model. It was snuck in there because the moon is a level 2. Okay, the moon doesn't go around the sun.
Yes, it does, but, whatever.
Now, don't be confused by that diagram. It seems like the sun is at the center, right?
Yeah, it sure does seem that way. What a crazy coincidence that I'm sure has no relevance to what we have learned about the universe since the times of Tycho Brahe.
So if you want, where it says Earth, imagine that that's at the center rather than visually seeing the sun at the center.
Okay.
Okay, so this is the Tychonian model, and guess what?
It makes more sense than the Ptolemaic model, but less sense than the Keplerian model that replaced it. You know, the whole march of scientific progress thing.
It resolves all of the Galileo issues, all right? All those things that I said were valid scientific objections, all of them can be shown to be, they can be rejected.
I mean, except for the objections that for some reason he didn't bring up, you know, the ones that I mentioned, like Coriolis and Foucault's pendulum. Weird that he doesn't address the actual physical experiments that are doable by everyday people with a bit of work and perhaps a bit of fundraising that absolutely demolish the idea of a stationary Earth.
In fact, the Tychonian model shows that you have the same model basically, but viewed from the Earth or from the sun. If you view it from the sun, it's called Copernicus. If you view it from the Earth, it's called the Tychonian model.
But that's just a coordinate transform. Doing a coordinate transform doesn't answer the question, does the Earth move? Instead, you have to actually do experiments to see the effects of Earth's motion, which you can, and when you do, you detect motion. Simple as that.
Okay, and you can show by doing mathematical transformations, no mathematician would argue with this, that the Tychonian model shows the correct motion of the heavens.
Of course it does. It just doesn't have any explanation for many physical effects, and if taken as somehow true, it breaks relativity in very real ways. And that means it breaks things like causality, something that Bob here seems to be very concerned with.
Now, this is a model that you probably never heard of. Even when I was studying physics, I never heard of the Tychonian model.
I think I've heard of it. I think I heard about it in my Catholic high school, which taught us heliocentrism in the broad sense, by the way. But hey, put in the comments if you've heard of the Tychonian model, and also whether you think Bob has actually studied physics, because based on what I'm seeing, I can't imagine that he's actually studied physics. He doesn't even know the difference between inertial and non-inertial reference frames.
Because I was educated, of course, in mainstream science beliefs, and that brought me to eventually the conflict with religion, with scriptures. And after investigation, I found out by digging deep into history
that evidence was less fun than just being a tradcath for him, so he rejected evidence.
You can find the Tychonian model.
Yes, that's true.
But it is ignored in modern textbooks.
I don't know or care about the degree to which that's the case. The fact is that it contradicts reality, so there's no real point in teaching it.
I guess a lot of people are going to ask why.
Yeah. Well, if we accepted the Tychonian model, which is a valid geocentric model...
No, it's not.
Then we'd have to go turn the clock back to the 1500s and say, hey, we rejected the geocentric model because it didn't, Ptolemy's model didn't obey it. But now it does.
We rejected the geocentric model because it didn't, Ptolemy's model didn't obey it, but now it does. What the hell does that mean?
So maybe geocentrism is right.
Yeah, maybe, you know, if all you have is a primitive telescope and you don't bother to check for any evidence of acceleration of Earth, but then that's just saying that if you don't bother to gather all the data, then you can believe whatever you want. If you don't want to look at rocks, then sure, you can believe in the global flood. If you don't want to look at genetics, comparative anatomy, ontogenetics, or paleontology, then sure, you can reject the theory of evolution. If you don't want to look at measurements of the speed of light, then you can reject relativity. If you don't want to look at what it actually takes to navigate the Earth, then you can reject the globe and embrace the flat Earth. None of that is good. The goal of science is to incorporate as much evidence as possible, not to limit it so that your pet idea can survive.
In fact, we can't prove it's wrong.
Yes, we can, quite easily. If you have a tall ceiling and can afford some rope, a heavy thing, and some hardware, you can test it yourself by making a Foucault's pendulum. Alternatively, if you own a kitchen scale and a test mass, you can test it by just flying north or south with your scale and then testing it without tearing it. That's all it takes. Really, just about anyone in the developed world who is middle class has it within their capacity to test the Tychonian model and show conclusively that it is wrong. Most people don't care to, since, we already dismissed this before anyone alive was born, so what would be the point? But for people like Bob, there's very little excuse for not even knowing that we can test it. Even many flat earthers at least try to come up with tests. Bob seemingly can't even be bothered to rise to that level.
And that means, well, maybe the spiritual world described in Scripture, maybe that's correct.
Non sequitur. Your facts are uncoordinated.
In other words, it's the conflict between the secular world of materialism, which is your underlying philosophy. It guides you in how you think.
Wrong.
Versus the open, scholastic model of realism and based on theology.
Calling a system based on Aristotelian silliness realism is on its own one of the silliest things in this entire talk. And it's a talk about geocentrism.
So it really comes down to fear. They're just afraid that if the Earth is the center of the universe, what else might be true?
Christianity is the largest religion in the world and has about 2.4 billion adherents. More than a quarter of the world is Christian. Virtually all of them reject geocentrism and accept the science on the shape and motion of the Earth. The people who proposed heliocentrism, like Copernicus, Galileo, and Kepler, were all Christians, specifically Roman Catholics. The guy who first proposed the Big Bang was also a Catholic. This is not a project to hide God or convert people to atheism or whatever, and if it were, it's failing spectacularly. I don't know of a single person who left Christianity because of the falsity of geocentrism. If you're a former Christian and you're comfortable doing so, please let me know if geocentrism played any part in your leaving Christianity.
Yes, isn't that interesting? Fear governs, right? It's fear that's not expressed, but it's sort of a wink and nod. If you have a meeting of scientists, they'll basically agree on heliocentrism.
Well, I have no idea what he said there, although I've been in many conversations with scientists and their fear of geocentrism isn't ever a thing I've heard a whiff of.
Although, as I'll point out, relativity this rejects the concept of any object being at the center, because everything can be used relatively. Everything can be measured relatively.
No, that's not what relativity means. This is why I say I don't think this man has studied physics, at least not from anyone competent to teach physics, because accelerating frames of reference are physically different than inertial ones. They can be differentiated by measurements. Further, even if we treat each planet as inertial when ignoring its rotation, we can still calculate the forces acting on them or the local shape of spacetime, depending on whether we want to think about gravity as a force or the curvature in spacetime. And when we do that, we find that the Sun is the object that is subject to the smallest changes in position, because it will be accelerated the least, or simply have the smallest geodesic path to follow through local spacetime. Further, it is gravitationally dominant given that it contains the vast majority of the mass of the solar system. Further yet, if we decide to choose the distant stars as our reference frame, then again the Sun is more or less the center of the solar system. So all Bob is saying is that you can use whatever coordinate system you want, which is mathematically correct, but then he's pretending that because there is no objective motionless frame of reference in reality, that means that maybe Earth simply isn't moving. But no, you can't do that. That's not how physics works. We can indeed test for Earth's motion and confirm that the Earth is moving in any reference frame, even a fixed Earth coordinate system.
Right, so it sounds like they're going to dogmatically and religiously hold to the position that the Earth is not the center of the universe.
No, normal people are not going to do that. We're going to rationally, and based on evidence, hold to the fact that any point in the universe looks like the center, because in the intergalactic void, space is expanding in all directions. So no matter where you are in the universe, the rest of the universe is receding directly from you. And by the way, that was discovered by Percival Lowell, who was apparently either an agnostic or a Christian, but also by Georges Lemaitre, a Belgian Catholic priest. Further, I just want to point out that just like with the flat Earth, there is really no reason for there to be some conspiracy. And the only reason given is just that, I guess, heliocentrism makes people not believe in God, just like the globe Earth allegedly does, except that just looking around the world should show you that neither does that.
Yes, this becomes scientific dogma.
Dogmas are required beliefs. Science does not have those beyond the basic acceptance of empiricism, which itself implies methodological, although not philosophical, naturalism. One of the ways that you can tell is that science changed its stance on this very question as a result of empirical data. It's hard to really express in words the level of irony in saying that the motion of the Earth and its position in the universe are dogmatic, given the degree to which these ideas have changed in science. If a group reforms their ideas about a topic in response to evidence, then one thing you can be sure of, regardless of whether they're right or wrong, is that their beliefs on that topic are not dogmas. Of course, it's also more than a bit ironic to have a Catholic complaining that people have dogmas, especially given how many of those the Catholic Church has accreted to itself in the last millennium or so.
Yes,
okay.
If there were such a thing.
Okay.
Wait, is that Bob acknowledging that he doesn't actually think science has dogmas? I'm confused.
No scientific arguments or experiments have ever refuted this model, okay, of Brahe.
Well, except for Airy's failure, Foucault's pendulum, critical things test for centrifugal force, Wolfie's test for the Sagnac effect, every single parallax measurement of the distant starlight, etc., etc., etc.
Etc., etc., etc.
Why haven't you heard about it? Well, we've just discussed one of the reasons why.
Except that I have heard of it, but hey, f me, right? I don't count.
Now, it's interesting. We have people who say, who are Catholic, that geocentrism is not a belief of the church.
I mean, if by the church we mean the church militant, that is, all those living humans who are united with Rome in a common communion, then by and large it isn't anymore. The vast majority of Catholics, including bishops, don't seem to believe it, so to the degree to which beliefs can be assigned to a group of people as a whole, then no, geocentrism is not a belief of the Catholic Church. If we want to say that all Christians are the church, not just the Catholics, then that doesn't change. In fact, I don't think I've ever found a Protestant or any Eastern Christians arguing for geocentrism, although I know of some Protestants who would argue for a flat Earth, which still has a motionless Earth.
Well, I would point out that we have beliefs like artificial contraception.
Does he mean the virgin birth? Artificial conception? Does he perhaps mean the Catholic Church's opposition to in vitro fertilization?
Okay, which are definitely dogmatic. And abortion. The laws against abortion.
Okay, he definitely means the opposition to these things. Sure, these are indeed beliefs of the Catholic Church in that they are widely held by Catholics and also actively promoted by the clergy of the Church.
Those are ignored, I would say, by possibly half of the so-called believers.
Maybe, but they do have the distinction of being pushed by the leadership and appearing as major ethical concerns in places like the Catechism. Specifically, abortion comes up in Part 3, Section 2, Chapter 2, Article 5.1, Respect for Human Life in the Catechism of the Catholic Church. So that's why I'd say that rejection of abortion, and by extension IVF, are Catholic beliefs. And this is backed up by the fact that I've had Catholic priests tell me that if I have questions about what the Catholic Church teaches, that the Catechism is a pretty comprehensive place to go for answers. Now, if all we mean by a belief of the Church is simply a belief that some members of the Church hold without that being cause for them to be excommunicated, then sure, geocentrism is a belief of the Church.
So you have a lot of doctrine of the Church that doesn't find its way into the belief of the common person.
But it makes its way into the contemporary official publications of the Church.
And geocentrism is just an exaggerated example of something that is almost universally rejected.
Including the teaching authorities of the Roman Catholic Church.
And sadly, growing up, the only people I've really seen cling to this belief were only some fundamentalist Protestants.
I haven't found any such Protestant, so I'd be fascinated to know who he means. But then I guess you can find Protestants believing just about anything. They're not exactly a monolithic bunch.
So it's interesting that they were wrong about a lot of the faith, but maybe this one part they happen to cling to the traditional teachings of the Catholic Church better than the Catholic Church clung to those teachings.
Of course they say that they're restoring the traditional teachings, but whatever, I don't care about this argument for the purposes of this channel.
Yes.
Because it's not a Protestant belief, it's a Catholic belief.
I'd argue that it's not really either, but whatever.
Yeah, it's a belief in Scripture as written.
Right.
Basically, those Protestant sects that believe in a literal translation have to come to a conclusion that it's geocentric.
Right.
And that the Earth is flat, that genetics works on the basis of sympathetic magic, that pi is a whole number, that God created men and women at the same time and after plants and animals, but also that God created men, then plants and animals, then women, that both Elhanan and David separately killed the same giant Goliath, etc. It's flatly impossible to believe the Bible literally as written. Bob showed us in the last episode that he certainly does not believe Genesis 1 through 3 as written, and instead he imports a bunch of idealism bullshit into Genesis 1 in order to make it so God doesn't really create anything on the first 6 days of creation. He just kind of thinks things up that he's later going to create in Genesis 2.
Okay, so the church retracted the Galilean edicts, the ones that I read to you from the Holy Office, okay? Although many people think that's been done, all right?
And shame on the Catholic Church, although I'd say that given that they're second only to the Republican Party in terms of hiding and protecting pedophiles, it's far from the worst thing that the Catholic Church has done in the modern period. Also, they should give back all that stuff they stole during the Crusades.
In this case, I want to prove that the Earth moves, okay?
But Bob thinks the Earth doesn't move.
Scientists asked the same question in the 1800s. In 1886, Michelson and Morley did a famous test whether the Earth moves through this ether. Now, what is the ether? The ether is the substance that we can't see that fills all space, and it provides the medium in which light moves.
Well, that's what the ether was supposed to be. Instead, it turns out that it just doesn't exist, and this was the experiment that really showed that to be the case. Once again, we've got a classic flat earth argument coming up here. I wonder how we get along with Nathan Oakley. I guess it depends on how much he likes the taste of balls.
Now, we know that waves in water require water to move. And extending that concept, the physicists agree.
Agreed. Past tense. That's important. They no longer agree.
That if you have light waving, that there must be something that's waving. And that something is called ether.
Well, that was the idea that was the most prominent at the time of the Michelson-Morley experiment. It turns out that light is not simply a wave, it is also a particle, and the wave is less of an actual disturbance of a medium and is rather better thought of as a probability function that determines where a particle of light will be when it is measured. This is probably most clearly seen in the famous double slit experiment. In this experiment, a light is shined through two narrow slits, and as one might expect from a wave, an interference pattern appears on a photoplate opposite the slits from the light source. But remember how light is also a particle? Particles are normally thought of as things like billiard balls. They can hit each other, hit one thing, bounce off with incident angles and whatnot, but they don't interfere with each other the way waves do. But perhaps they actually only interfere in mass numbers, since technically a wave in, say, water is actually just the massive interactions of large numbers of water molecules, each of which individually behave, for the most part, like a tiny billiard ball, albeit one with a polar electrical charge of strength that is significant compared to its mass. Well, we can simply test this by sending a single photon at a time through the slits, and letting the experiment run. If light really is a bunch of billiard-like balls, which rely on there being lots of them to cause interference, like in water, then when we do this, we shouldn't get an interference pattern. The thing is, though, when this experiment is run, you still get the interference pattern. But on top of that, you can keep track of each individual photon hit separately. You can watch tiny little billiard ball interactions on the sensor that slowly form an interference pattern. So a single photon can interfere with itself, like it's a wave, but every time it actually interacts with something, it acts like a particle. This means that our simple intuitive ideas about how waves and particles work at the human scale does not work when it comes to light. Instead, it is better to think of the wave aspects of light as regions of higher and lower probability of detecting a photon, and not as the actual fluctuation of some material medium. There is no need for a luminiferous ether, and the very fact of wave-particle duality rather neatly removes even the possibility of such a thing, since light actually interacts as a particle and only travels as a wave.
Ether also appears in the scripture as the firmament.
No, it doesn't. Look, the firmament isn't a mystery. In Hebrew, the word is Rקיע. It means something beaten out like metal. It separates the waters above from the waters below, and it is spread out like a tent over the Earth. It is clearly a solid dome over a flat Earth that keeps out the cosmic ocean above the Earth. It's the thing with the stars in it, the thing the sun moves across. Nothing anywhere in the Bible even hints that it's a medium that light travels through that suffuses the cosmos. Further, in Ezekiel 1:22, there is a Rakiya spread out above the heads of the living creatures in the vision, and it sparkles like crystal. Does the ether sit above things and sparkle? No, it's supposed to be invisible on its own and suffuses the whole cosmos, not be in an identifiable place with a particular shape. Calling the firmament the ether requires that one ignore the actual use of the word in the Bible. Further, if Bob doesn't like the Masoretic text, the word for firmament in the Septuagint is stereoma, from the verb stereo, which means I make strong, I strengthen, or I make firm. So stereoma is a thing that is strong or firm. Yet the ether is supposed to be so insubstantial that you can move through it without ever noticing a bit of friction. The same word is used for the firmament in the Septuagint of Ezekiel 1:22. In the Vulgate, the word is firmamentum in Genesis 1:6 and firmamenti in Ezekiel 1:22, which are both forms of the same word, firmamentum, which is itself a word invented for the Vulgate, but which is pretty transparent in etymology. It is from the Latin word firmare, which means fix or settle. It's supposed to be immovable and firm. You know, like a dome over the flat Earth. I'm sorry if this bothers anyone, but the flat earthers are simply correct that the Old Testament or the Tanakh or the Hebrew Scriptures, or whatever you want to call them, depict Earth as a flat surface with a solid dome over it, and says nothing about how light travels or even what light is. God just creates it one day, and there it is.
Okay? And we could have a whole hour discussion about the firmament.
We could indeed. And we would find that Bob doesn't have a single leg to stand on, because his version of geocentrism with a globe Earth is just as unbiblical as heliocentrism is, which is to say, completely.
But let's go to the Michelson-Morley test. What are they testing for?
They were testing for ether drag. You see, they knew that the Earth was moving from numerous observations independent of any particular prediction with regards to ether, and so they were testing the hypothesis that there existed a medium that is the thing that waves when light waves travel. The idea was that if a medium existed, then the motion of the Earth through it should change the speed of light, with light going faster when traveling in a direction opposite that of Earth's movement, and light going slower in the same direction.
Well, think if you were in a car and you rolled down the windows and put your hand out, you could tell whether you were moving by the wind that you would feel on your hand.
Yep.
Okay, in this case, the hand would be the detector of motion. Okay?
Well, relative motion. One could be driving a car on a windy day and happen to be aligned to the wind and moving at the same speed as the wind compared to the ground. Then your hand would not feel any wind.
So Michelson-Morley said, okay, if the Earth's going around the sun...
No, that was not an issue in the experiment. The experiment was not to detect the motion of the Earth. That was both well established already and not disputed in the conclusion to the experiment. It was to detect the ether, the thing that was hypothesized but not yet demonstrated to exist, unlike the motion of the Earth, which has been very conclusively demonstrated in multiple ways that we've already gone over.
At one time, it should be moving through the ether in one direction, and then 6 months later, remember this is the heliocentric model, 6 months later it'd be moving in the other direction. So there must be a difference between the two.
Provided that the luminiferous ether exists as postulated.
Because if you're moving through even stationary ether, the wind would be detected in opposite directions.
Yes, the only option for no ether wind, if the ether exists, is that it would move in sync with the Earth, and given how insubstantial it's supposed to be, there's really no way to account for an ether that does that.
All right, so they wanted to know how fast is the Earth moving through the ether?
It was more, is the hypothesis of the ether correct? Although, if it had been, then they would also have measured the speed of Earth relative to the ether within a margin of error.
And they did the test using an interferometer, which is the same as the hand outside the car window.
No, it's not the same at all, but whatever. If there had been a change in the speed of light with regards to the vector of the light's travel, the interferometer would detect it, so who cares?
It's a device to measure the speed of light, and they found that there was no difference.
That's true.
So what would you say, Gene, if in that car model, you stuck your hand out the window and you found out that there was no wind? What would your conclusion be?
Well, since I can see the countryside rolling by, I would conclude the wind is going at the same speed that I am. If this happens when I'm going in a big circle, then I'd have to conclude that there simply is no air out there, which would raise questions about how I'm breathing, but whatever, this isn't a terribly good analogy anyway.
I would assume that I'm not moving.
Well, that might make sense if literally the only indication was the feeling of wind, but it's not. We have conclusive evidence of the Earth moving, so given that and the invariant speed of light, the correct conclusion is the one that Michelson and Morley actually came to, that the hypothesis of the luminiferous ether is wrong, and that's why Einstein stepped in and proposed relativity, which starts with the observed fact of reality that the speed of light in a vacuum is always the same for all observers, regardless of their own relative motion, both to other observers as well as the source of light.
That's it. Common sense says the Earth isn't moving. Okay?
No, not okay, because that means we now have no explanation for Coriolis, stellar parallax, stellar aberration, the Sagnac effect, Foucault's pendulum, or the observed changes in the felt force of gravity based on latitude. If you want to claim a stationary Earth, you're going to need to explain every last one of those in a parsimonious way that beats the current understanding in terms of explanatory power. Pointing out that the hypothesis of ether fails isn't even an attempt to do that.
Now, you have just indicated logic, but what would happen if you said the Earth isn't moving? Well, then you'd be saying it's geocentric, and then we're going back to the conflict, the Galilean conflict, and we're saying that the Earth possibly is not, is at rest, rather, and it is not moving.
Yes, which would be at odds with far, far more experiments, which means that since we know the Earth is moving through numerous other observations and experiments, the parsimonious explanation is that there is no luminiferous ether, which constitutes the physical medium through which light moves. And in the decades since, we have also refined our understanding of light to realize that the waves of light aren't actually waves of any medium. They are instead probability functions.
But what did mainstream physics and Einstein said?
That since this overturns none of the independent and quite conclusive evidence of the motion of the Earth, that there must be another explanation for how light propagates?
To resolve the issue, they said there's no ether.
Yep, and then they backed that up experimentally. One example of such an experiment is the previously discussed double-slit experiment. But also, just the photoelectric effect, the thing that Einstein got his Nobel Prize for, also shows that light isn't just some wave in a medium. So I guess now it's time to talk about the photoelectric effect. It had long been known that shining light on certain substances could knock electrons off, providing an electrical potential, or in other words, generating voltage. The problem, though, was that the voltage did not behave as predicted if light is a wave. In that scenario, the wavelength of the light should not matter much, provided that it was small enough to meaningfully interact with the object in which voltage was to be generated. Instead, the determiner of how much voltage is generated should be the amplitude of the wave, or the brightness thereof. But when tested, certain wavelengths simply could not generate any voltage no matter how high the amplitude was. Einstein solved this conundrum by realizing that light came in discrete particle-like quanta called photons. The energy of an individual photon was proportional to its wavelength, and the amplitude of light is actually a measure of the number of photons. So if a photon did not have the energy to knock an electron out of its orbital, then no number of them could do it. This was the beginning of quantum physics, and also a great example of how light cannot simply be thought of as a wave that needs a medium. While the mathematics of waves is certainly vital to describing the behavior of light, light fundamentally is not a wave in the same way that the waves of the beach or sound waves are.
That's why you don't find it. But if there's no ether, light can't move through nothing.
It moves through space-time. That's a thing in my book.
Right? Through empty space. We have starlight coming, or sunlight, and all the light that we get from the heavens comes through empty space.
Yes, it does, and no, that's not intuitive, but that's science. Science is all about not caring about intuition, because it's not evidence, and instead, taking empirical data as evidence. That's specifically why so much of science, like relativity and quantum mechanics, flies in the face of intuition. And yet they are vital for things that we use every day like GPS, automatic sliding doors at the grocery store, and the very device you're using to listen to this, and that I use to produce it. If our ideas about relativity and particle physics were fundamentally wrong, we couldn't make and operate most of the electronics that are produced around the world.
But the space isn't really empty. It's got ether.
Sorry, that's precluded by experiment, most notably the very experiment we're talking about here.
Okay, it's like saying in the car model, well, there is no air.
Yeah, and a thing that isn't usually true in real life. But I'd like to point out that it was true when the Apollo astronauts were driving around the moon. So saying there's no air as an explanation for why you didn't feel the wind on your hand is at least sometimes a good explanation.
That's the reason that you don't feel any wind. And that contradicts logic.
No, it doesn't. Specifically, if other experiments confirm that there's no air or ether, which in both the cases of testing for ether in the real world and driving around on the moon is the case. There simply is no air in that case and no ether in the case of figuring out how light works.
Because we know that there's air, because we'd suffocate without it.
As would the Apollo astronauts, and yet there not being air is still why they didn't feel any wind when they drove around. But yes, the requirement for air to live is where the analogy breaks down. And it's not really surprising to me that an idiot like Bob not only doesn't recognize that as a limit to his analogy, and instead he just leans into the disanalogy. I'm thinking he's stupid, although I will say I do think he's lying when he says that he has studied physics, just like flat earthers are lying when they say that they know the globe model better than any normal person.
Okay, the response is that from the mainstream is the ideology trumps truth.
No, the luminiferous ether was the universal consensus. If anything, it was the ideology that got trumped by data. This is an example of a paradigm shift, the very opposite of what happens when you're dogmatically bound to an ideological position. That science has had paradigm shifts is it not being bound by ideology. Reality is exactly the opposite of what Bob thinks it is in this case.
We're going back, in other words, to the conflict between science and the church.
Personally, I reject the conflict thesis as a useful way to understand the interaction of the church and science. Normally, it's atheists who dislike the church that advance the conflict thesis. It's a bit weird here to see a Catholic accept the conflict thesis because he hates science, but I suppose that's where we are. That's the sort of position I more associate with fundamentalist evangelical Protestants. Maybe this is like the horseshoe theory, but for Christianity. And I would now say that if anyone knows of any geocentrist, young earth creationist, or flat earth Eastern Orthodox Christians that may have made videos that are worth responding to, let me know. I'd love to complete the trifecta of Chalcedonian Christianity.
So if relativity allows Earth to be the measuring frame at rest,
which it doesn't,
then why does mainstream physics insist that the Earth orbits the Sun?
Stellar parallax and stellar aberration. Also, because using that model, space agencies can launch probes to other planets and they get where they're going.
This is one of many conflicts, many contradictions.
It might be a conflict for Bob, but it's perfectly internally consistent in science.
If you can choose anything you want to be the frame at rest, and that means including the Earth, then why don't you allow a geocentric model?
Oh, because non-inertial reference frames can't be said to be at rest in relativity, and the Earth is a non-inertial reference frame. It turns out that just badly misrepresenting physics doesn't actually change science, despite how much wrong earthers might like it to.
Again, it's all basically religious. It's all based on the conflict between materialism and spiritualism.
Only if that conflict is the conflict between caring about data and not caring about it. If Bob wants to define spiritualism as believing that the data don't matter, then okay, I won't try to stop him. But that just means that the position he accepts is the position that evidence and what's actually true don't matter at all. I think that's a weird position to take for a guy who worships someone who said, "I am the truth." It seems like that kind of person should care about what the truth is in the first place. But hey, as I've said, I'm not anyone's pastor, priest, bishop, rabbi, imam, confessor, or anything like that.
Okay, let's look at the scientific resolution of this problem. Many people don't know this, but physics is broken up into two branches: kinematics, which is purely mathematics applied to science. It's the science of measurement. So if you measure distance, velocity, acceleration, all right, different properties of motion, then you're doing kinematics. Relativity is only valid for measurements.
Relativity is only valid for measurements. I'm not even sure what that phrase means. That happens with this guy a lot. He says things that don't really mean anything. It's almost like he has no clue what he's talking about.
And I give examples there of different relative motions. Another branch of physics is dynamics. Dynamics is the study of predicted future motion. Notice that I underline that. Kinematics is the science of measurement. Dynamics is the study of predicted future motion.
Get on with it. Yes, get on with it.
Get on with it!
So in order to find out how fast something is moving, I can measure it. Okay, that's one option. That's kinematics. Or I can use the values of force and mass and other properties to predict what the value will be before I measure it.
Thanks for the high school refresher, Gramps. Of course, high school physics is also enough to show that geocentrism is bullshit, so I'm not sure why he thinks this is a good idea for him.
So this is prediction of the future.
Which is haram, by the way. Only Allah knows the future.
This is obviously what you must have to do rocket launches, to do trips to the International Space Station, to the moon, and so on.
Yeah, which raises the question, how do geostationary satellites work if the Earth doesn't move? So for any orbit, the orbital period is a function of the mass of the body that one is orbiting and the distance from that mass. The farther you are away from the thing you're orbiting, the longer your orbital period. So if you're at the altitude of the International Space Station of about 420 kilometers, your orbital period is about an hour and a half. Something special happens at an orbital radius of approximately 42,164 kilometers, though. At about that height, the orbital period around Earth is 23 hours, 56 minutes, and 4 seconds, or the length of one sidereal day, the amount of time it takes for the distant stars to rotate once relative to you. Now, this is called a geosynchronous orbit, and a geostationary orbit is a special kind of geosynchronous orbit, one where the orbital plane is the same as the equatorial plane of the Earth, and which has no orbital eccentricity. That is, the orbit is perfectly circular. So if the Earth is not moving but orbits work, and Bob seems to think that orbits do work, a satellite at the height for a geostationary orbit will appear fixed in its position relative to the background stars. If the Earth does move, then the satellite will appear fixed in position relative to the surface of the Earth. And what do you know but the geostationary satellites are at fixed positions relative to the ground, and not the stars. And you can tell if you've ever tried to set up a satellite dish for satellite TV. They point at particular points in the sky, always towards the equator, because that's how geostationary orbits work. Additionally, here's footage compiled from images of the Himawari 8, a Japanese weather satellite in geostationary orbit. If Earth weren't moving, then either this satellite would be falling to Earth, or the Earth would be spinning under it. Yet again, an actual test of the fixity of Earth that shows that indeed the Earth is moving.
So this is dynamics. It uses the energy concept to determine equations of motion, the laws of physics.
Neat, but are we going anywhere with this?
Now, general relativity says that there is a principle called general covariance. Don't be scared by the name.
I'm not.
The laws of motion in dynamics are valid for all observers. That's what it means. So you can use the laws of physics to predict motion according to general covariance, which is what Einstein believed in his general theory.
And demonstrated, which has been verified by countless subsequent observations and experiments.
To predict what will happen no matter how you are moving. If you're on Earth, if you're on a plane, a train, if you're on the space station, if you're on the moon, no matter where you are, the laws of physics are valid.
So far, so good.
I'm going to give you a simple example to show that that's totally false.
Okay, everybody. Bob is going to overturn most of physics all on his lonesome using a PowerPoint presentation and a stock image of someone hitchhiking. Let's go.
And I call it the hitchhiker paradox.
I'm sure it will someday be right up there with Zeno's paradox and Haldane's dilemma in terms of importance to the history of science.
Okay? It's based on a specific law of motion, Newton's second law. The acceleration of an object is proportional to the force applied divided by the mass of the object being accelerated.
Well, that's approximately true at relatively low speeds. Really, in relativity, the equation is this. acceleration equals the inverse of rest mass times the space-time vector, or 4 velocity, all times force minus velocity times force times velocity over the speed of light squared. At low speeds, all of the terms but rest mass and force are negligible, and so acceleration as force divided by mass is fine.
In other words, the more push or pull you exert on an object, the faster it will change its velocity.
Yes, that remains true in both simple Newtonian mechanics and in relativity.
However, the bigger the mass is, the more massive, more matter it contains, the slower, the less acceleration it will have.
Yep, that's how proportionality works. Thanks for the high school math lesson.
This is a dynamic law. If you ask me what is the kinematic law for acceleration, it's the change of velocity over the change in time.
I'd rather say that's just a definition of acceleration, but sure.
Okay, so notice I can predict acceleration with F equals ma, or A equals F over m, Newton's second law. Or I can use kinematics and measure the change in velocity over the change in time, which is acceleration.
Don't make me pull out the Monty Python clip again.
All right, we're going to take the point of view of the hitchhiker, which is shown in this diagram. We have a car accelerating straight down a highway towards the hitchhiker. So accelerating again means moving at an increasing speed.
No, it means changing velocity. Speed is distance over time, velocity is distance over time with a direction, and acceleration is the change in velocity over time.
Not constant speed, changing speed.
Yep, except that it's changing velocity, not speed.
Okay, next slide. This is the point of view of the driver. The driver sees the hitchhiker on the side of the road. The driver considers himself to be at rest.
No, he doesn't, because acceleration means that he's in a non-inertial reference frame, and the acceleration on its own causes him to feel a fictional force pushing him in the direction opposite that of the acceleration vector. Therefore, he cannot be treated as at rest. This is what Bob fundamentally does not understand, and it is why I say that he is lying when he says that he has studied physics. Heck, if you've ever been in a car, you felt the car's acceleration, and you know that it's not the same feeling as when the car is at rest or moving at a constant velocity.
Okay, which we said is perfectly valid, according to Einstein.
Yeah, Bob said that, but he's wrong.
And so what we have is the hitchhiker accelerating towards the car.
No, we don't. We have the hitchhiker at a constant velocity, which we can measure as any unchanging velocity. It depends on our reference frame. But he is always treated in this case as at a constant velocity, ignoring gravity for now, which I think both Bob and I are happy to do in this case.
If the car were going south at 50 miles per hour,
which is a constant velocity, okay,
then the driver would see the hitchhiker moving north at 50 miles per hour.
Yep, which describes a situation in which neither is accelerating, which is not the situation Bob described.
Okay, I'll call that the driver and the hiker reference frame, which is the same as the Earth.
Those labels are unobjectionable, sure, but the fact that Bob doesn't understand acceleration at even a high school level is troubling.
Okay, so we have the driver heading north. He has a mass of mh. The h stands for the hiker.
Okay, so he said out loud that the driver has mh, but then he said that h stood for hiker, and the slide says that mh is the mass of the hitchhiker and that the mass of the driver is md. So I think he just misspoke.
And the m for the mass. The acceleration is ad, which is the acceleration of the driver. And the driver's mass is md.
Okay, cool.
So those are the things that you can measure. In the hiker's frame, the hiker predicts the inertial force from Newton's second law is F equals ma, where this is applied to the driver. So we have all of the D's.
May Bob get all of the D's he deserves and none of the ones he wants.
This predicts, in common sense terms, that the driver will feel a force on him as he's accelerating.
Something borne out in real life if you've ever been in an accelerating vehicle.
So we know from common experience this is true. When your car speeds up, you feel the force of the seat back on your back. And that's the acceleration called inertial force. And this formula predicts what that force will be, and it is measured with a spring scale, and it turns out to be correct.
Yep.
I think the cops are out to get Bob. He should watch out.
So Newton's law applies, in this case, to the hitchhiker measuring the driver. Okay? Now let's look at the driver frame.
I bet this is where it gets really dumb.
Okay, we're going to do a little math because we have to. We have to show what the driver measures and what he predicts.
Not the math! Anything but the math!
The acceleration of the hiker is measured by the driver.
Right off the bat. No, it's not. The driver feeling a force measures his own acceleration. You can't just observe a change in the rate of change in an object's distance and assume that the other object is accelerating. That's why accelerometers don't measure the acceleration of distant objects. They measure the acceleration of the accelerometer. Because fundamentally, before you can decide if another object is accelerating, you have to figure out if you are, and by how much, and in what direction. Then you can subtract that acceleration from the acceleration of the other object you're measuring and get the direction and rate of their acceleration.
We're looking for AH, the acceleration of the hiker as seen by the driver.
Which is 0, neglecting gravity, and after we subtract the acceleration of the driver, okay.
This is a measurement, so kinematics applies, and relativity.
But this isn't using the relativistic formulae, just Newton's, which for the purposes of a hitchhiker and a driver is perfectly reasonable, but nothing that we're doing has anything to do with Einstein in any particular way. Just like hitting like has nothing to do with Einstein in any particular way, but I'd still really appreciate it, and maybe share the video. The algorithm here on YouTube is a fickle thing, and there's no way to predict if this video is going to be a flop on which I lose money, or a huge success that drives new traffic to the channel. You hitting like and sharing the video makes the latter much more likely, so help a dinosaur out.
So AH is equal and opposite to AD. The acceleration of the hitchhiker is equal and opposite to the driver's.
Nope, it has an actual value. The other is 0, as measured by both if we ignore gravity. Really, a better example would have been 2 spaceships or something, so I don't have to keep saying if we ignore gravity, but whatever. I'm not convinced that Bob thinks spaceflight is real.
Okay.
No, Bob. I'm pretty damn far from okay.
In this case, the hiker would be moving south. Step number 2, what is the inertial force, FH? That's the force on the hiker, as predicted by the driver.
Well, mh is some number, we'll call it 100. The acceleration is 0, and 100 times 0 equals 0. So the predicted force is 0. Fun times.
Not measured, predicted. So we got to use dynamics, Newton's second law, F equals ma. And we can substitute for AH minus AD, because the accelerations are equal and opposite from kinematics.
Nope, we can't. We have to subtract the measured acceleration of the car from the acceleration of the hitchhiker as measured just as a second derivation of distance with respect to time. Which means perhaps I should go into what velocity and acceleration are, and even what derivatives are. First, we have to start with distance, which is a pretty simple concept. How much space is there between 2 objects? Distance is just a simple number with units, it's not a vector. Now, if you track distance over time, it may change. If you were to plot this on a graph, you would get a curve that describes a change in distance over time between the 2 objects. And let's just assume that one of them is you, the listener. But we don't have speed yet. Speed has units of distance over time. But if we want to see moment-by-moment speed rather than average speed, we have to do something a little fancy. If we take the curve we get from measuring the distance at different times, we can assess the curve's tangent. You might remember from school that a line is tangent to a circle if it touches a circle at only one point, and that this line is always perpendicular to a line drawn from the center of the circle to the point that the tangent line touches. You can also think of this as a line that is sort of parallel to the circle at that point. In that, at that one point, it is going in the same direction as the curve. This idea can be expanded to curves that are not circular. If you measure the tangent of the distance curve that you've generated, and then graph those values, you'll generate a speed curve. If at any point your distance curve is flat, and the distance value doesn't change, then your speed will be 0. If the distance curve slopes up or down linearly, then at that section, the speed curve will be flat at some positive or negative value. In this way, we say that speed is the first derivative of distance with respect to time. But if we take that speed curve and make another curve out of its tangent, then we have the second derivative, acceleration. In case you're wondering, the third derivative of distance with respect to time is called jerk, and the fourth, fifth, and sixth derivatives are somewhat informally named snap, crackle, and pop. Although they're rarely ever needed for anything, so that's more of a joke than a serious science thing. Anyway, I had previously said that velocity had a vector, and the above explanation just used simple numbers. Well, a vector is a way of describing something along more than one axis, usually 3, although any integer can work, although good luck trying to picture more than 3 in your head. Vectors usually have 3 axes in physics, x, y, and z, which correspond to the 3 dimensions of space. A vector in Euclidean coordinates has a value for each axis which uniquely defines one point, and the distance from that point to the origin defines the magnitude of the vector. Another coordinate system that can be useful are polar coordinates. In this system, points are defined by their horizontal angle from an arbitrary direction labeled as 0, and then their height above or below the horizontal plane on which this origin sits, and last by their distance from the origin. Both of these are useful in various circumstances, and both end up working out the same way. Yet another example of why changing coordinate systems doesn't really change reality. Now, in many cases, the acceleration we're dealing with in motion is parallel, which means that the direction of the vector is always going to be the same or exactly opposite between the objects in question. Since in this case we can use a Euclidean coordinate system, and since we can align just one axis to the direction of motion, if we do this, we find that 2 of the axes are always going to have a value of 0, so we can just ignore them, getting back to simple speed. So what's the point of all this? Well, since acceleration means you're not in an inertial reference frame, you can't treat yourself as unmoving and expect physics to work out properly. For example, if you ignore the force accelerating you, and you use Newton's laws to figure out the trajectory of an object moving in your accelerating car, you will find that it deviates from the predicted path by curving in a direction opposite that of the direction of the acceleration. For example, if you and I were in a large car that was accelerating and we wanted to throw a ball to each other, and we were standing such that a line between us was perpendicular to the direction of travel, then the ball should always curve towards the back of the car, and we would have to compensate for this. In case you're wondering, yes, this is essentially the same phenomenon as the Coriolis effect, and yes, it does show conclusively that the Earth is spinning. Now, if we were to repeat this ball throwing exercise standing on the ground, we would not see any such deflection. For this reason, we know that we cannot treat all reference frames the same way, because physics does not work the same way in all reference frames. Accelerating reference frames are not the same as inertial or non-accelerating reference frames. On the other hand, if we were in the car doing the same ball throwing exercise, but the car was traveling at a constant velocity, we would not need to compensate for any deviation from the predicted trajectory of the ball due to the acceleration, because there is no acceleration. So physics would work the same for us in the car as it would work for the person on the side of the road. This is the fundamental thing that Bob misses.
And that's not 0.
Yes, it is, because when you subtract the linear acceleration of the car from the observed acceleration of the hitchhiker has 0 acceleration. And remember, we know that acceleration can be measured in the accelerating reference frame, and we can do it with something as simple as tossing a ball, although fancy accelerometers use things like sensitive springs or pressure-sensitive components that generate tiny voltages, which are then converted to acceleration. But whatever means we use, we can and do measure acceleration.
Okay, that's what the symbols mean, not equal.
Sure, but then they're being used incorrectly, because it does equal 0 if you do the math right, which Bob won't do.
MHAD is not 0 because neither M nor A is 0.
Except that AH is actually 0.
But what is the measured force on the hiker?
0. Sifr. Par.
Well, here we draw on common sense.
Something that generally is a bad idea in science.
When a car accelerates past you on the highway, do you feel the acceleration, the same acceleration that the driver feels?
No, I do not. And the fact that Bob thinks that all the world's physicists and engineers have never thought about this and so are just getting physics wrong is a little weird to me. Like, if physics actually operated the way Bob thinks it does, the modern world simply wouldn't be possible. And yet buildings get built, planes fly, satellites orbit, etc. It's almost like physicists and engineers know what they're doing, and maybe it's Bob who's wrong.
No.
No, you feel nothing. There is no inertial force on the hiker, even though the driver would predict it using Newton's second law.
No, he wouldn't, because he's the one feeling the force. So to predict what's going on for the hitchhiker, he'd have to subtract out his own acceleration. This isn't that hard to figure out. If you're measuring an object's distance to you and its acceleration is always exactly equal to yours, then you know something funny is happening. Either you're not accelerating or it isn't, and that's the situation here. This is the most basic shit. Also, Newton is pre-Einstein. If you're using Newton, you're not doing relativity. And like I've said, that's fine in most circumstances, and it's certainly fine in the circumstance of a car and a guy on the side of the road. But even if Bob were right that Newtonian mechanics was inconsistent, it wouldn't mean anything for Einstein. You'd have to show why those equations don't work.
So we know that the hiker feels no force from the accelerating car.
Ignoring wind, which I'm happy to do.
So here is the conflict. We predict that there is a force on the hiker.
Yeah, Bob predicted that. But anyone with a brain more powerful than that of a koala didn't, though.
Just as it was on the driver, using Newton's second law.
But using it incorrectly.
But the force on the hiker is zero when measured.
Yeah, which to a normal person would indicate that he's done the math wrong. Not that the math itself is flawed, since chances are that if you're using centuries-old tried-and-true physics formulae and getting the wrong answer, you're probably using the formulae wrong, rather than that the formulae themselves are the problem. Now, that's not always the case, which is why Einstein had to step in the first place. But just from a statistical standpoint, you're far more likely to be misusing the math than the math being wrong, and that should be your first assumption. Only after finding that no, both you and all the people you check with who know what they're doing all agree with you that you've done the math right, should you then consider that maybe the problem is with the equations. That's what happened with Einstein. There were discrepancies in things like the orbital precession of Mercury that kept cropping up, and no one could use the equations of Kepler and Newton to produce the observed precessions. So Einstein came up with new equations that did. But Bob isn't Einstein, and is in fact doing the math wrong. Because when actual physicists and engineers use this equation in this kind of circumstance, they get the right answer. Hell, I got the right answer, and I'm not a physicist or an engineer.
Okay, we're not considering any of the wind that might, influence the hiker as the car goes past.
Right, I already covered that.
So the laws of physics, in this case, F equals ma, are only true predictions in the Earth or the lab frame.
The lava frame? What did you hear him say? Tell me in the comments.
That's the only frame in which the laws of physics are valid.
Nope, they're valid in all frames. It's just that not all frames are the same, and you need to account for that.
So now we have more confirmation that geocentrism is correct.
Bob not understanding physics at the level I'd expect of a 15-year-old isn't exactly evidence that geocentrism is correct. In fact, I take it as evidence that anything he says should probably be taken with a grain of salt. One thing you don't need to take with a grain of salt is that my Patreon is a good deal if you enjoy my videos. It starts at just $1 a month, and you can get a 15% discount if you make an annual pledge. You get access to my super secret Discord server and about 6 months of early access. There are more perks at higher tiers, and it really helps keep me financially stable and able to keep producing content like this. I know times are tough, and I don't want you to give more than you can afford, but it really means a lot to me if you can't afford to give even $1. It all adds up.
The Lord God has made this world so that only on earth are the laws of physics obeyed.
If that were true, then no one could ever make any moving object with any kind of consistency. We can, so that's not true. Planes, trains, automobiles, and even rockets all work just fine, and people do experiments in physics in space all the time. Every day, satellites that wouldn't work if Bob were correct about this reliably transmit data to Earth and receive it from Earth. NASA probes get where they're going, and people manage to accelerate just fine.
If you're moving with respect to the Earth in any way, and you try to use the laws of physics, you will fail.
I'm going to put some gameplay up of Kerbal Space Program, which is in fact a Newtonian physics simulator, where physics works just fine, while I talk about this bit. Einstein's most important thought experiment, in my opinion, is what I'd like to call the infinite elevator. In this, you're in an elevator in deep space, where there is no significant gravity that you can measure. Or imagine that you're in a universe that's empty apart from the elevator and its content, which includes you. Also, importantly, there is no window in the elevator, so any experiments you do can only have information from inside the elevator. In the first case, the elevator is moving at a constant speed, and the mechanisms of the elevator are perfectly smooth. The question Einstein asks is, what experiment can you do in the elevator to tell that you're moving at all? The answer, of course, is that there is none. All of Newton's equations work as expected with no gravity. The other experiment is one where the elevator is accelerating constantly. For convenience, we'll assume that it's accelerating at 9.8 meters per second, the value of the acceleration due to gravity on Earth. For one thing, unlike the first experiment, you can tell that you're accelerating, and the constant acceleration has to be factored into any physics equation you might use. Now, the important insight from Einstein was that if this situation is the same as being under the effects of actual gravity, then gravity is acceleration. And also, since a light beam would be deflected from a straight path in the elevator, Einstein predicted that light was deflected by gravity. It turns out that he was right about that, and that was measured during an eclipse where the apparent positions of stars changed in the exact amount that Einstein predicted. But importantly, notice that physics always works in the elevator in all conditions. You just have to account for the gravity or acceleration. And the two situations, accelerating or not, are distinguishable. And further, neither elevator is on Earth, so there simply is no truth to the idea that physics only works on Earth. That's simply Bob failing to understand the absolute most basic things about physics.
Now, physicists know this.
There's nothing to know. That's just Bob's wildly insane take that's very, very wrong.
Okay, and they call this fictitious forces. Well, I'll get to that. I'll get to that in a minute.
I'll get to it now, because Bob, apparently, doesn't know what a fictitious force is. A fictitious force is one that only appears to exist in a certain frame of reference. We'll go back to the example of centrifugal force. If you were looking down on a centrifuge as it spins, all you could measure is momentum and circular motion. There is no centrifugal force. Now hop into a centrifuge and spin it up, and you will feel a very strong centrifugal force. The difference is that you are treating the interior of the centrifuge as stationary, which means that there is an apparent force towards the outside of the centrifuge. An example of fictitious force on Earth is Coriolis. Because we like to know where things are on the surface of the Earth, while on Earth, we usually measure things as if Earth were stationary. Since it's not, it induces a deviation on objects that move north or south. From the perspective of the Earth, this is seen as a Coriolis force, which causes the rotation of storms like hurricanes and cyclones. From outside Earth, looking at it as it spins, it is, once again, just momentum. Fictitious forces aren't some attempt to rescue physics from the horrors of living in a geocentric universe that we want to treat as if it's not geocentric.
So why is the hiker able to make true predictions? Because he's in the Earth frame.
Nope, it's because physics works, as long as you actually do it right. Bob didn't, and that's his problem here. I hate to say it, but maybe he should have stuck to the philosophical ramblings.
He's stationary on Earth. Why can't the driver make good predictions with the laws of physics?
He can, he just actually has to do it right. Bob didn't, and that's his problem here.
Because he's not in the Earth frame. Okay? Anything else besides the Earth frame, you cannot make dynamic predictions.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
Okay, I'm just repeating in a simple way Newton's bucket paradox. You can look that up. It's the first case in 1687 where this was noticed. Newton in the lab makes correct predictions of a rotating bucket, but if you were on the bucket, you would not make the correct predictions.
Yeah, you have to account for the fictitious force if you're going to use a coordinate system fixed to the bucket. That's the solution. That's the whole thing. It's not more complicated than that.
All I did was simplify it, and everyone agrees that the driver feels a force.
Yeah, which means we can't treat him as stationary. We have to account for that in the physics.
And the hitchhiker does not, even though they're predicted the same force.
Responding to this again is a torment beyond any even I would wish upon my enemies. It has already been addressed more times than I have flayed the skin off a weakling just to hear his screams.
Now, when I first heard this fictitious or fake forces, I thought it was hilarious. I heard this in graduate school.
We really are at flurf level nonsense here. Haha, the forces are a fiction, so they don't real, so science am fake. This guy has the intelligence of warm mayonnaise.
I'm paying good tuition to go and listen to a teacher tell me that unless I'm on Earth, everything that I try to predict is fictitious.
No, he wasn't, because that's not what fictitious forces are. In fact, they're far more common on Earth than they would be in outer space. The people on the ISS have to deal with far fewer fictitious forces than anyone on Earth. In the intergalactic void, you'd encounter almost no fictitious forces besides those induced by your own rotation. And of course, you'd experience the Great Devourer, but that's a different matter.
I didn't pay tuition for fake physics.
And he didn't get fake physics. But of course, him, not knowing what physics is, and apparently already having a dogmatic bias against it, decided that since the physics wasn't confirming his dogma, that it was the science that's wrong. That's been the theme of this whole video. To put it in terms that Dan McClellan might like, he's nakedly putting dogma over data.
I wanted the truth.
No, he didn't. He wanted his dogmas confirmed regardless of truth, and you can tell because his response to well-tested physics was to misunderstand and dismiss it. And of course, this is me actually accepting that he went to grad school. This is the kind of physics you can learn in high school. I doubt very much that he managed to get through an undergrad program that involved physics if he's intentionally this bad at it.
And the truth is that it's the Earth.
And none of the physicists can figure out that their math doesn't work and that their predictions aren't borne out. This guy is just a Principal Skinner meme, but in real life.
So to get around this, Gene, to provide a subterfuge.
All of physics is just right there in the open. You can read the papers, you can run the numbers, you can make your own predictions. It takes effort, and you'll need to actually learn how to do it, so it's not something that any guy off the street can do with no training. But there's no subterfuge, nothing is hidden, there's no conspiracy. Science is one of the most open endeavors that humans have ever embarked upon. It depends on openness so that scientists can check each other's work. This is not to say that no scientists are ever biased or ever lie, but what it does mean is that in the long run, the data win out over any dogma that aren't true, even this guy's dogma of geocentrism.
Right? That they do understand what's happening.
Well, that part is true, and it's a little crazy to me that Bob never stopped to think that maybe, since that's true, that he might be the one who doesn't understand what's going on.
They create this model that you are in a non-inertial frame. In other words, the Earth is an inertial frame by definition because it obeys the laws of physics.
Except that it measurably isn't. Even if we ignore gravity, we know it's not. Now, in most cases, that isn't too important to physics, since the amount of acceleration on Earth is fairly negligible, apart from gravity. So we often treat Earth as if it were an inertial reference frame. Since in cases like balls on a pool table or cars driving down the road, things like Coriolis are going to be such small factors that they're well within the margin of error of any measurement that will matter. But they do matter if the question is the Earth an inertial reference frame? And the answer is no. He's confusing simplifying assumptions with real life, just like when flat earthers confuse a simplifying assumption of a flat and stationary Earth in a flight model with an admission of the reality of a flat and stationary Earth. This man is operating at the level of JM truth.
The sun, we're told, is a big gaseous ball burning in space in a vacuum. By the way, since we're on the subject of vacuums, fire, the element by which the sun exerts its energy, and I don't care if it's nuclear fission or what, it's still fire, okay, needs what element, folks, in order to continue to burn? Oxygen. But wait, there's no oxygen in space.
Interestingly, that's also the level at which Matt Powell operates. Although I don't see any evidence of either of them being as abusive as Matt.
Oh, Matt's taking advantage of me. Dude, you will go to hell! I am not joking! Look at me!
Matt, stop.
Look at me!
Stop.
You look at me right now!
Stop!
That
I came here
has nothing to do with this.
I came here.
We are going to talk about this.
You're going to smile.
You are insane! You think I am yelling too hard? You have lost your mind!
Stop!
You're gonna talk to me.
No!
You're gonna talk to me right now.
I'm getting out of here.
You're acting like a woman. Why don't you talk to me like a man?
Acting like a woman. I came here for the stupid
You're
window.
acting like a woman, dude. And we can't fix the window.
Nothing
I'll
more,
take care of the
nothing
window.
less.
But you know what?
Then
We
take
need
care
to
of the
take
window.
care of this.
No.
You go to the Von Gotts and tell Mrs. Von Gott, oh, Matt called you a witch. You know that's right. And I never said that. I said they practice certain things like witchcraft. But I never ever demeaned her character. And for you to just go over there and bold-faced lie, just like you've done with Daniel Botham and my brother, just like you've done with all sorts of people, then you're going to get angry at me for yelling at you. You're crazy.
I'm not crazy.
You are insane. You have lost your mind, Jeremy. And I love you too much just to sit here and say, oh, well, you're fine. Because you're not.
But the car is not in an inertial frame.
Which is why we shouldn't treat it as one. The level of acceleration is very significant compared to the scales and masses of the bodies involved, unlike, say, Coriolis force when applied to a game of pool.
So they say, if you're not in an inertial frame, then you won't get the correct prediction.
Unless you account for the acceleration, which you can do, and which he didn't do. So he seems to kind of understand, so now it's starting to seem like he might know better. And yet if he does, then he must be lying about physics. I don't know. Let me know in the comments if you think he doesn't understand physics, or if he's just lying for Jesus.
This is true. But what they leave out is that all reference frames are non-inertial, which are not Earth frames.
What I believe is dumb.
Nope. Any frame of reference that isn't accelerating is non-inertial, and that doesn't actually technically include Earth, but in many cases the difference is negligible, so we're allowed to just pretend.
So any motion with respect to the Earth is a non-inertial frame.
Wrong.
If you were on Mars, it would be just as inertial as Earth, which is to say it's not actually an inertial reference frame, but for most cases, you can just pretend it is.
So notice how they try to make it sound like there are another non-inertial frames besides the car.
Well, there are, because any accelerating reference frame is by definition non-inertial, because its motion cannot be explained solely by inertia. How is he not getting this? Is it possible for him to actually be confused like this? Like, if he's actually this stupid, how does he accomplish things like paying bills or wiping his ass? Maybe he doesn't. For all I know, he's the stinky guy in a shelter or mental institution.
That's not true.
Yeah, which is why no one says it.
Anything that moves with respect to the Earth is a non-inertial frame.
This reminds me of Sal Cordova and John Sanford realizing that they can't actually support genetic entropy unless they just change the definition of fitness, which of course they do, and thereby make the whole idea meaningless, since it wouldn't actually lead to extinction, which is the whole point. Here Bob seems to realize that the real definition of inertial and non-inertial mean that physics works just fine. So he just comes up with his own arbitrary definition, and like Sal and his life partner Sanford, he just hopes you don't notice.
Okay, this has not been resolved.
Because it was never at issue to be resolved. Everyone who matters figured it out on day one.
It's been buried, ignored, okay, but it is another proof of geocentrism.
Then Bob should publish it, and he should make better predictions about the movements of things that aren't on Earth than science does. Of course, he won't try either, because fundamentally he's wrong, and I think that on some level he recognizes that. But he can't let that rise to the surface and impinge upon his conscious experience.
All right, so the evidence is that the laws of dynamics are true in the Earth's reference frame, and only that frame. Any predictions from the Earth frame will be valid. Others will be called fictitious or false.
All right, guys. Sometimes you are wrong in life.
Okay. I would rather say all this is proving is that the Earth is a selected place in the universe where only the laws of physics are valid.
Yeah, of course he would like to say that, but all he's done to back that up is just ignore that some frames of reference can't be treated as inertial, since they're not, pretend that because in some cases Earth can be treated as inertial even when it's not, that it actually is, and misdefine what inertial and non-inertial reference frames are in the first place. If I were to toss this logic back at him, I would probably say that Catholicism is untrue and I can prove it, because the magisterium of the church hasn't found the bones of Jesus. And if you're Catholic, you can see why that's a stupid statement on multiple levels. First, the magisterium is a teaching authority, so it can't really do archaeology. So that statement betrays a fundamental misunderstanding of the words involved. Second, Catholicism rather depends on Jesus' bones not being on earth, so that can't be evidence against Catholicism.
Now, in order to distinguish this, which is a concept which is ignored, at least till these modern days.
Yeah, but it's ignored for the same reason that flat earth is ignored by scientists. It's so obviously wrong, and we've known that for so long, that what's even the point to people who have science to do in even bothering with it? You might as well say that you have a new explanation for fire, and it's that tiny elephants with small suns in their ears grab fire from their ears and use their trunks to blow it onto burning objects. That's an idea that will be ignored by chemists, not because they're hiding the truth about fire, but because we know what the truth about fire is, and that ain't it. It's also so far from anything that even could be true given what we know, that the only real response it deserves from a chemist is just laughter. Now you might wonder then why I'm giving this attention. Well, first I needed a break from anti-evolution content. Also, it's because since I'm not busy doing science, I'm free to counter pseudoscience, and also hopefully teach a few things along the way, like experiments that you can do to demonstrate the motion of the Earth, or explaining concepts in science and math like derivatives, curve tangents, curve normals, fictitious forces, and the different kinds of reference frames. I'm not pushing the knowledge of humanity forward, but I am fighting a rearguard action against those who would drag it back. I don't know if geocentrism is ever really going to take off, but I wouldn't have thought that flat Earth would have.
Boy, was I wrong.
So I might as well head geocentrism off at the pass, just in case.
Think of the following. Kinematics, the branch of physics that does measurement, obeys relativity.
No argument there.
Okay. Dynamics, which is the part of physics that does prediction,
also follows relativity.
Predicts geocentrism. So you cannot use relativity in dynamics.
Weird then how everyone who does physics seems to think the opposite. I guess they just haven't spent enough time graced by the sublime genius of a guy who doesn't know how to test for acceleration.
That's the conclusion.
Well, the conclusion of people who think that human learning just kind of stopped sometime in the Middle Ages.
You know. Morons.
As an epilogue, let's use the lab frame for all applications of physical motion.
The lab frame? What the hell is the lab frame? The frame where a laboratory is treated as fixed? What lab? Why are we using it?
That's the basic conclusion. You know, Newton and Faraday and Maxwell and all of the great scientists of the past, they made their measurements on the Earth frame. And that's why it's always been assumed that in any other frame that the laws of physics would also be valid.
Well, they did all live on Earth, but humans have since sent scientific equipment elsewhere, and guess what? The laws of physics work just fine.
That turns out to be incorrect.
If that were true, we couldn't do science away from Earth, so Mars rovers wouldn't work, the Hubble telescope wouldn't work, and the Apollo programs would never have gotten to the moon. The Venera probes would have never been able to do science on the surface of Venus, probes to Saturn like Cassini would have failed, the experiments on the International Space Station wouldn't work, and yet, all of them do work. And the physics that are used to get them where they're going, and to operate once they're there, is relativity. I mean, in some cases, it's a simplified version, more like Newtonian physics. But that also works on the moon, on Mars, on Venus, and around Saturn.
Okay, only from God's good green earth can future motion on Earth and in the cosmos be truly predicted.
Weird then how when NASA wants to predict the time and location of future solar eclipses, they use a model of the solar system that is centered on the barycenter of the solar system, which is more or less the sun, and that has Earth moving. Also, Bob already said that heliocentrism could in fact be used to calculate the future position of objects in the sky. So he's wrong on practical terms, and he's also contradicting himself. What a weird way to do an epilogue, just showing his whole entire ass.
So if you want to make predictions, you have to use the Earth.
That might be compelling if people didn't routinely make predictions correctly while using other reference frames. It's like telling someone it's impossible to cook eggs while they're standing there making an omelet just fine. And professional chefs who cook eggs every day exist. Also, you can tell how hungry I am by how often my analogies turn to food.
Now, NASA will tell you, well, we make measurements from the spacecraft.
Because they do. Are we about to hear about NASA lies like we're hearing from a flat earther?
And that determines what the spacecrafts will do next. Yeah, but they've got ground tracking stations, and those ground tracking stations are the ones that determine what the laws of physics will be.
Nope, or at least not in all cases. Apollo famously used a system called PINGS, or PGNCS, which stands for Primary Guidance Navigation and Control System. It was contained in both the command and lunar modules and worked without any need for communications with Earth. It was designed for use both during planned communication blackouts, like when the craft had the moon between them and the Earth, and in cases of unplanned communication loss, such as malfunction or damage to the comm system. It used a 3-axis gimbal with 3 gyroscopes to measure orientation, and a telescope to sight stars. This system was designed to work with Earth not even visible, which also means that there would be no way to measure the position of the craft from Earth. The aforementioned Cassini craft sent to Saturn also relied on onboard guidance that referenced the stars. What Bob is saying is just flatly incorrect according to the people who fly spaceships.
Now, the viewer for this presentation take it or leave it, basically, but you have a choice to make.
I mean, not if I'm being intellectually honest, I don't, but let's hear him out.
If this is the truth, what I've presented, that geocentrism is correct, then you have to believe and support the geocentric truth as part of revealed truth, as part of the dogma of faith.
Well, first, that if is doing a whole hell of a lot of work in that sentence. But second, no, I don't. If all that Bob said was true, which it wasn't, and the obviousness of that would be hilarious if it weren't so sad, then all I would have to do is support it as part of empirical science. I wouldn't need any dogmas, I wouldn't need any faith, and geocentrism on its own would certainly not establish the dogmas of the Catholic Church as true, especially since geocentrism isn't even one of those in the first place.
Before this, you may have had invincible ignorance and not had any knowledge of geocentrism. But this makes the difference.
No, I had heard of it. I'm aware of both its use in history as well as modern cranks who push it, like Robert Sungenis. I'd respond to him, but he makes even fewer claims per unit time than Bob does, and most of what he had was just a bunch of philosophical musings I don't super care about. But at least I could address those.
All right, what are the remaining things that we should look at? Well, there's a conflict between Newton's law and geocentrism.
It seems like where we should have started, since that on its own precludes geocentrism in more than one way.
How can the sun orbit the Earth if Newton's laws of gravitation are valid? A smaller object should rotate or orbit a larger object.
Nope, it's about mass. A neutron star with the mass of the sun would be about 14 kilometers in diameter or 7 kilometers in radius. So smaller than the island of Manhattan. If we replace the sun with this 14-kilometer ball that is much, much smaller than the Earth would still orbit around it. At least we found one way where Robert isn't like a flat earther. Flat earthers are actually better at knowing what density is than he is. They're not good at it, but they're better than Bob.
So how can the sun orbit the Earth?
Good question. I bet the answer is stupid.
The quick answer is it's the motion of the ether that does it.
Drink for confirmed prediction.
But that requires a lot of explanation.
And for the ether to exist, which, it doesn't. Also, how is it substantial enough to move the whole damn sun around, but we don't feel it at all on Earth? Shouldn't it be swirling around us? And even if it's not, when we just walk around, we'd have to be walking through it. Why don't we feel it?
And you have to talk about the role of firmament and ether in Genesis.
Oh, the firmament! Well, here's Past Dapper already talking about that. No, it doesn't. Look, the firmament isn't a mystery. In Hebrew, the word is Rקיע. It means something beaten out like metal. It separates the waters above from the waters below, and it is spread out like a tent over the Earth. It is clearly a solid dome over a flat Earth that keeps out the cosmic ocean above the Earth. It's the thing with the stars in it. the thing the sun moves across. Nothing anywhere in the Bible even hints that it's a medium that light travels through that suffuses the cosmos. Further, in Ezekiel 1:22, there is a rakia spread out above the heads of the living creatures in the vision, and it sparkles like crystal. Does the ether sit above things and sparkle? No, it's supposed to be invisible on its own and suffuses the whole cosmos, not be in an identifiable place with a particular shape. Calling the firmament the ether requires that one ignore the actual use of the word in the Bible. Further, if Bob doesn't like the Masoretic text, the word for firmament in the Septuagint is stereoma, from the verb stereo, which means I make strong, I strengthen, or I make firm. So stereoma is a thing that is strong or firm, yet the ether is supposed to be so insubstantial that you can move through it without ever noticing a bit of friction. The same word is used for the firmament in the Septuagint of Ezekiel 1:22. In the Vulgate, the word is firmamentum in Genesis 1:6 and firmamenti in Ezekiel 1:22, which are both forms of the same word, firmamentum, which is itself a word invented for the Vulgate, but which is pretty transparent in etymology. It is from the Latin word firmare, which means fix or settle. It's supposed to be immovable and firm. You know, like a dome over the flat earth. I'm sorry if this bothers anyone, but the flat earthers are simply correct that the Old Testament or the Tanakh or the Hebrew Scriptures, or whatever you want to call them, depict Earth as a flat surface with a solid dome over it, and says nothing about how light travels or even what light is. God just creates it one day, and there it is. So yeah, that's the role of the firmament in Genesis. It's a solid dome over a flat Earth, not the medium that light disturbs as it travels.
That's another future topic.
So in this whole topic, the problem that gravity absolutely precludes geocentrism is just going to be addressed by pointing to something we know doesn't exist, and then pretending it's in the Bible. Wow. I thought I couldn't lose any more respect for the intellectual prowess of Bob here, but apparently, I was wrong.
And then finally, we have the model of St. Hildegard, doctor of the church.
I hope he means Hildegard of Bingen. I like her because she is one of the first people we know of to have constructed a language. It was crude by the standards of modern constructed languages like Klingon, Esperanto, or Dothraki, but still, it was very cool, even if we don't have a lot of documentation on it.
Who in the 12th century was given detailed information about spiritual things and also of the workings of the universe, and including details of Genesis.
In other words, she made up stuff and she thought she was channeling divine wisdom. That happens a lot in history, including with people who aren't Christians and who channel things that contradict Christianity. So you'll have to forgive me for not taking channeled mystical stuff from a German nun as the gospel truth. As previously stated, though, she did make up some cool stuff, so as it stands, I'm still a fan.
It's amazing as I read through the research of St. Hildegard.
When I was writing the script and he used the word research, I was taking a drink of water, and I nearly spit it out all over my computer screen and keyboard. Boy, is that the wrong word.
How many different things I discover. I just discovered yesterday that Lucifer and Satan are two different beings.
What, so he's just now looking into the Bible and what it has to say about Lucifer? In that he's a king of Babylon, as it is explicitly stated in Isaiah 14, right there for all to read? Neat that it took him this long to realize that. And of course by neat, I mean pathetic. After this, he goes on a bit about his conjecture about Satan and Lucifer. I don't care, I'm skipping it. He does at least confirm that the Hildegard he's talking about is indeed the one that I was talking about. One thing he does not do is address the problem with Hildegard's model, and that's it. He just keeps going on about how cool Hildegard was, and doesn't make any more arguments about geocentrism. Since I don't care to address anything else about Hildegard of Bingen, I guess we're done here. I can't say that was impressive, but there is one last thing he said that I want to talk about.
That goes back to the difference between the way the Catholics have an epistemology, which starts with theology, and the last thing we use is science.
That is why you fail.
So there it is. To really agree with Bob, you have to first accept his theology. But why would you when it directly contradicts so many basic facts about reality that you can check on yourself? You shouldn't. If Bob is right about Catholicism, then the only conclusion to draw is that Catholicism is demonstrably wrong in its beliefs. Now, I do happen to know that Bob does not represent Catholics, so to my Catholic audience members, please know I do not think of you as being in the same mold as this guy. In summary, we got bad philosophy, blatant misunderstandings of not just reality, but 8th grade physics, an appeal to visions, and what I consider to be a veiled threat of eternal damnation. In other words, not a single good reason to accept geocentrism, and a number of problems for geocentrism that are fatal to the idea that just weren't addressed except by lies about how spacecraft are navigated. I guess I shouldn't expect much more than that from a guy who seems to be cribbing notes from flat earthers. Oh well. I hope you enjoyed this series. If you did, then please hit like on this video and tell me what you liked in the comments. If you didn't like it, then hit dislike and let me know what the problem was. Either way, please subscribe if you haven't, and turn on all notifications so that occasionally YouTube might tell you about my content, if they feel like it, regardless of your wishes. And remember, if you want to support what I do, please consider joining the channel memberships or the Patreon. I'm the Dapper Dinosaur. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Ben Tobin, Tapioca Weasel, Arrow Dodger, Caleb Anderson, Dan Sheedy, Eleron Teller, Phil Cavara, Ian Chen, Kelvin Brostock Van Manen, Landon Knoll, Mabbity Babbity, Sphincter of Doom, Volis, North Texas Fossils, and John Ackerman. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.